Hi, Cecile.
Hi there, Sil. How are you?
I'm doing pretty good. How are you doing? Nice to see you.
Yeah, I'm so excited about this room that we have now, and I think we will get a lot of inputs from the audience because, I really tried to choose this particular topic today because I know that Tesla has inspired a lot of people, and maybe there are still many things that we don't know about Tesla that the audience will be able to share with us. And yeah, today we have other moderators who will be joining us, and also one MJ who is doing a podcast and may have some research, inner research of Tesla, maybe more than the popular ones that are being here. So yeah, I will invite you once again. As you know, you are the life of quantum photonics because you open the rooms and you close the rooms. So yeah, I will invite you once again to play the music as we are waiting for the other moderators to come in and more people to come in the room to start our current discussion. So I'll make you mod for now, and if you want, you can go back down or you can stay after we have started the room. So in advance, thank you so much for all the effort and dedication that you have given quantum photonics.
Thank you so much for all those kind words, Cecile. It's my honor and pleasure. All right, here we go with our theme song. Okay, the mic is yours, Cecile. Hi, MJ, and hi, Sierra, and Rajarshi.
Yeah. Hi, Shira. Hi, MJ, and hi, Rishi. We are very excited to have this room tonight with you. And actually, I just canned my reading today because for Tesla, I bank on my general knowledge that I have. It's so hard to maintain a daily room of hard science, math, and tech every day. But, I'm so glad that I have very competent and excellent people who had joined me today to be co-moderators. MJ and Rishi is here. And yeah, I would like to introduce MJ. He has a podcast who is talking about he's talking about creative geniuses, and maybe follow him and try to check out his podcast. And I know that he had researched deeply into the life and history of Nikola Tesla, and he will be making a presentation. Rishi also will be making a presentation here, a short introductory topic about Tesla, and we will probably be asking questions, presenting facts, and trying to have more questions. And later on, we would like to invite the audience to share with us, whatever they want to say about Tesla, if they have questions or they have some facts that they would like to share with us. As you know, Tesla is a very remarkable figure that has influenced the way we try to live, has changed the world. And even up to now, among the said to be more than 300 patents that he has, a lot of them has not been exposed yet, actually. And it has indeed really changed the world. And on my side, I am very interested in him because, Tesla is a polymath. He was a polyglot. And aside from having this very remarkable genius about creating things, he was a person who had other interests as well. And what I know about Tesla so far is that it is said that he tried to get his physics and engineering degrees, but he actually never finished. And he came from parents, his father was involved, was a pastor in their hometown, and his mom was not formally schooled at all, but she had an eidetic memory. And that is something which is remarkable that Nikola Tesla had. So here with me is MJ and Rishi, who will be talking to us more about Tesla, and will be making their presentations here as we try to introduce the topic. And I'd like to say hi to Shara, if she could speak for now. Yeah, hi Rishi. I cannot see you. So are you here?
Oh yeah, this new feature, I can't see the moderators anymore, can we?
Maybe if I go out for a short while, I will be able to see you again. But I didn't leave the room yet, so when I come back, I will see you, so that I can make you moderator. So I think, today we had requested you and Hansen and MJ to help us host this forum about Tesla. And I would just like to ask if you would like to make a first introduction about Tesla. Then after that, MJ will do his own introduction. Is that okay with you?
Yeah, sure. I'd love to. Very happy to. Thank you. So, one of my favorite scientists ever, Nikola Tesla, and for many reasons, many things that were inspiring about him, many things that were depressing to know about. Some of the things, for example, how lonely he was, how he lived largely by himself, as far from society often as possible, and the heartbreak of his inventions and how some of them never saw the light of day because of the fierce competition from Edison. And we wouldn't even say fair competition in certain regards. So just to maybe start off where I understand his story started off majorly. When he graduated, he got a job at the Edison Electric Company. And very early on in his career, he brought many amazing inventions to the Edison Company. The only problem was that engineers at Edison's company weren't paid very well. And he was barely given a living wage, just enough for him to afford a room's rent and enough food to be able to come to work every day. And while he was here at Edison's company, he made many patents, many inventions. Unfortunately, and any of those were obviously proprietary to the Edison Electric Company, and therefore he did not receive appropriate remuneration for those inventions while he was working there. And at a point when he first came up with his idea for an AC alternator which would create AC current, he offered to sell it to Edison for for a not too large sum, so that he could break free of Edison and make his own way. But Edison did not believe in the prospect of AC current. He was pushing for his own modus operandi, which was DC current, and he'd already secured the funds and the investors, the large investment required to be able to make the infrastructure to make this happen. So, and thus began their almost 20-year war, trying to make their paradigm the existing one. And we know that today we use AC almost for all our long-distance power transmission needs. But it's very interesting to see how that fight played out, and how after 20 years of inventions, but Nikola Tesla did not have the magnetism that maybe it was that was required of not just a scientist but an inventor to be able to secure the investment for his inventions. Over the course of his life, he lived in solitude for the later parts of his life. He moved to was it California, somewhere in the US, where there was very good wind shearing and very good static electricity in the air, and continued his experiments there, mostly in solitude. So I'll just very quickly go over some of the most amazing things that he's invented, and just as a brief introduction. So we've all heard of vertical takeoff and landing. It was first theorized by Leonardo da Vinci, but there was an unsuccessful patent, not unsuccessful, but an early design invented by Tesla also for a vertical takeoff and landing gear. Nikola Tesla has invented a valve which has no moving parts. A truly amazing invention, because with no moving parts you have no wear and tear, and it's entirely designed like a series of buckets, where if you which can be micro-sized. In fact, you can make a micro electromechanical system out of this design. It's so simple, and the result is a slightly leaky valve which prevents most flow in one direction but completely allows flow in another direction with no moving parts whatsoever. So quite a significant invention. Tesla, I think, sorry, I got thrown out. But to me, the most amazing inventions by Tesla were his systems for worldwide electric and communication systems. He had a design for how you could transmit power from one point to another without the use of wires. And in fact, he wanted to make this the norm across the world. We would have free electricity. We would not have to be paying electricity bills if Tesla had his way. And he designed the Wardenclyffe Tower, which was a prototype for the system. Initially, he secured funding from JP Morgan for the Wardenclyffe Tower for a transcontinental communication system. Of course, JP Morgan, being a banker and one of the very rich philanthropists and businessmen of his time, was very interested in investing in communication technologies. In fact, even today, the forefront of human technology has usually been communications. And so, at first, JP Morgan was very excited by this and funded the prototype. But eventually, when the radio telegram system was competing with Tesla's invention at the time, Tesla thought to compete with this more effectively, and so he wanted to expand the Wardenclyffe Tower to not just do communication, but also wireless power transmission. At this point, JP Morgan was a little hesitant to continue to fund it. He thought, no, we should focus, or whatever he thought, and he withdrew his funding, which is why the Wardenclyffe Tower is the only prototype that exists today. And today we have to pay through an electricity meter for the electricity that reaches our house, because we still use wired transmissions. But essentially, why this was so amazing is because he wanted to leverage the Earth's magnetic and resonant fields to be able to send electricity from one point to another by basically making the Earth itself vibrate, by basically tapping into the natural vibrations of the Earth. And it's like, hey, I want to send you a message, I'm going to make the entire Earth shake. And that was the significance of his vision. He did not think small. So these were some of the more significant inventions of his that never saw the light of day. And maybe we can break down some of what he did and more of what he invented as we go along. But yeah, would anyone else like to chip in here?
Yeah, thank you, Rishi. Of course, we will break down some of his inventions and other life stories as we go along. Now, I would like to welcome Hansen. I would like to ask him if he would also like to make a short introduction, or would rather just join the general discussion later as we also go along and we interact with the audience that we have. What do you like, Hans? Do you like to make a short introduction about Tesla? Or yeah.
Oh no, I'll join the discussion later, and I'm actually quite interested in. I read about the this power transmission, but I would like to know more details about it because any radiation is power transmission. So it must be something special, particular about this. Either, as Justin was saying, about the resonance. So the radio transmission. The reason that we can we can receive radio transmission from one end of the earth to the other is because the reflection from I think I forgot the name, the magneto some sphere that on the atmosphere that actually reflects the radio wave and bounce back and forth. So otherwise the radio wave will just go into the space and will not go to the other end of when the curvature scatters the reflects and the radio wave, and it will go up the other end. It is reflected back. So I would think that must be something else that's doing the transmission make it more efficient. But anyway, so that's we can discuss later.
Maybe I can expand on that a bit for now. So the difference, actually, full disclaimer, today's scientific consensus is that this would not have worked effectively. But it wasn't just the idea of communication and radio wave transmission, but to be able to effectively transmit power as well, which the only difference is that you're not just bouncing off radio waves that can carry a signal, but you also need significant power to be transmitted, which means less attenuation as far as possible. And Tesla intended to do this over wireless transmission, which means over the air. And we know that radio waves attenuate not so much over the air, but the power of the electrical signal is very quickly attenuated over free space, right? So the consensus today is that this was not theoretically possible. But just to quickly go over the elements, so it was based on electrical conduction with an electrical charge through the ground, as well as a theorized conducting layer in the atmosphere. So primarily through the ground, and it consisted of a grounded Tesla coil, which acts as a resonance transformer transmitter, which she thought would be able to create a displacement of Earth's electrical charge by alternately charging and discharging the oscillator's elevated terminal. So basically, he had two significant inventions which he intended to basically manipulate the Earth's internal electric and magnetic fields. This was the first, where he intended to use surface charges which traveled along the surface of the Earth, because electricity conducts through the Earth much faster than through the air, right? So the reason he was experimenting in California was that during during the season of thunderstorms in that area where he was experimenting, the air itself was extremely conductive because of the ionization of the air. lightning would cause ionization, which would make the Earth's atmosphere also as conductive as is conducive for power transmission. But of course, you can't rely on that for usual operation. So it was primarily designed around modifying the Earth's electrical charge along the surface of the Earth through alternating oscillations. There was another invention, which was how he intended to do mining. How he intended to do what it was called prospecting. Right, prospecting is the act of finding minerals under the earth. So he used a very similar method where he would use electric and magnetic pulses that would go under the surface of the earth and reflect back. And the reflectance, of course, might be standard for the average without much deviation. But when you discover a mineral, you would get a different reflection depending on the electric and magnetic properties of that metal. And so you would be able to send electric and magnetic waves down to the earth. And when they're reflected back, you'd be able to get a measure of what sort of minerals you could find underground. So a very similar prospect, which was to use to create a displacement in the Earth's electrical charge. His theory was. So and why this was cool is because his theory was that you could place a resonator on two opposite ends of the Earth, or at another point in the Earth's surface, and one would act as a receiver, which is tuned to the same frequency, and electric current would be able to flow through the Earth between the two because there's one resonator and one receiver. And so that's how he believed that waves of electrical current from the sending tower could be made to reflect back from the far side of the globe. Now, this is really cool. So suppose I'm in California and someone else is in Japan. You would send a wave from one to the other, causing a standing resonance wave. A standing wave which could be as long as the Earth's diameter. So what is a standing wave? The way we use a wind instrument like a flute, the reason it works is that there is a column of air, and we are able to decrease or increase the size of that column of air. And when we blow into the flute, the sound vibration bounces along that column of air, and it stabilizes into a standing wave. The standing wave has certain properties which are really cool. For example, they're more stable, and therefore that's we use standing waves as regular practice in many applications. If you just take a rubber band and pluck it, you get a standing wave between the two ends of that rubber band. So essentially the point is that with these two towers which are resonating with each other, you're able to create a standing wave that's across the earth, along the surface of the earth, which allows for more effective transmission of electricity between those two. And that was the theory. Today's, we don't believe it to be possible, but it was quite a grand plan when he first came up with it. But yeah, that was just an explanation of it.
Now, Rajarshi, thank you for that explanation. It's wonderful to have your knowledge on stage. I just wanted to ask you a follow-up on that. So you've said that the consensus today is that it likely wouldn't have worked, but the consensus in Nikola Tesla's time that alternating current wouldn't have worked was the same. You know, they discounted him as well, and then, you know, of course, until he proved them wrong, and then even then it was difficult to prove until he received all the funding. So as someone I know who also has great admiration for the man, do you think that he may have made the proper adjustments when seeing perhaps any limitations in his initial designs? And if he still continued to have the proper funding from someone like a JP Morgan who regretfully pulled that funding, do you think he would have still been successful?
So it's a very good question, and I might not answer it too directly, but I would say it doesn't matter if it would have been successful. It should have been tried. Because we still don't try to manipulate the Earth's electric and magnetic fields today. We aren't doing that in any capacity. We haven't even tried to do what he said we should do. So this magnetic electric prospecting, the possibility of sending electricity along the Earth's surface, these are things that we still haven't tried today. And just as another way of answering, if you look at how Tesla actually achieved success, it wasn't because his science made sense. He never had success communicating his science except when he built really cool prototypes that he showed to his investors and impressed them with that. So whether it was the AC motor, whatever, do you know how he finally won the argument against DC? It was very simple. He took a chair. They were using this was a time when the electric chair was first being invented, and Edison's electric chair was horrifying. It would cause really bad smell. The person would sometimes not die, very often not die, causing intense pain. And DC is extremely painful. And of course, he was trying to make DC the norm, and he was saying, hey, let's electrify people with DC. And it took so much more power. Tesla came and showed how much more humane it was. He came and gave a demonstration saying that AC was harmless by creating the Tesla coil. Literally showing AC current shooting up into his arm and doing nothing but making your hair stand up. These kinds of displays where you're able to communicate to the public what the advantage is or what the mystery is behind what you're doing was the only way that he found success, whether it was the AC motor, whether it was any of his inventions. Up until then, nobody understood his genius until he was able to take some time to translate it into a demonstration that was understandable by them. So now, the Wardenclyffe Tower and this gigantic display of let's send power by modifying the Earth's electric fields, these were things that took a lot of money. And to his credit, he was still able to convince the richest man of his time, JP Morgan, to cough up the money for a prototype. The only problem was, by the time he was quite old towards this project, and it was a long term, of course, right? He had to change the world, and he was going reportedly senile and reportedly quite towards the spiritual side of things rather than focused on business. And these were things that turned JP Morgan off being a businessman. But my firm belief is that with people like this, even if they're wrong, you need to give them the space and the funding to be able to experiment. We learn things from their mistakes more than their successes. Yeah. But yeah, that's a long answer.
Yes, no, you're absolutely right. I firmly and totally believe, agree with you, but I also believe that I think he would have figured it out. I really do. And we've so many times written him off, and history has written him off. But there should be a Nikola Tesla statue in the capital of every country, of every city, because of the fact that all of our power still uses his invention. It's kind of mind-boggling. Like the other week, I was in Manhattan here, and I walked on his corner. There's the Nikola Tesla corner, which is right next to the New York Public Library, where the Schwartzman building, where he would routinely walk and feed his pigeons and such. And I'm like, okay, great, there's his corner. His statue must be nearby. Of course, no statue, no nothing. He gets a corner. I mean, the injustice done to this man continues to this day, and it's just through people like you, Rajarshi, and other people who discover him and his true works and his life story, and are compelled, even just by the story, who, like myself, I'm not an electrical engineer, I'm not a physicist, but as a creative, just his story and his mind draws me in, and that's what compels me to him. And so, yeah, I think he would have done it. And from my understanding, reading in the John O'Neill book called Prodigal Genius, John O'Neill was a contemporary of Tesla, and he actually spoke with him and interviewed him and such for this book before Nikola Tesla passed away. And so in that book, John O'Neill writes that this whole scenario surrounding J.P. Morgan and the funding for Wardenclyffe, that the way it transpired was that J.P. Morgan, gave him $150,000 for the initiation of the project and Wardenclyffe Tower on Long Island and such, and it was going well. Nikola Tesla hadn't completely informed him what the extent of the project was, but obviously because he had received already the support of George Westinghouse and he had this incredible reputation, J.P. Morgan thought it was a great investment. Until one day he met up with Tesla. He came and visited the grounds and the lab, and he asked him more directly, what is this project all about? And Tesla told him flat out, because Tesla basically never told a lie in his life. I mean, if you look at all the details and the anecdotes, and he told him this is for the proliferation of free energy worldwide, and this is the wireless energy system he was developing. And of course, for someone who's an investor, like a JP Morgan, who's all of his friends are oil barons and people who deal in coal, and their entire fortunes are built off of these things that are basically power-based, wealth, energy-based wealth. He looked at him, dumbfounded, and he said, okay. And he thought about it later, and he started to pull the funding gradually. He didn't immediately say to Tesla, I cannot support this. He privately continued to fund him so that he could live, so that he had enough money for his expenses, but he started to gradually pull the funding so that Tesla couldn't do the experiments he wanted to do. And publicly, that sent the message to other investors that were curious about this very successful, brilliant genius, that, the great investor JP Morgan seems to not be into this wireless energy idea. I guess it's not a good investment. And that is one of the true tragedies, I think, of this story. And like you said, it should have been allowed to be tried, right? It was worth it. And they just didn't know how to make money off of free energy. Yeah.
On that part, actually, when Rajarshi was talking, it's about the actually. Well, it's also related to the dissipation, not dissipation actually, spreading of the energy, because the energy is basically 1 of r squared. But the thing is, it's not the issue here, because you can have a wave dish, or even phase array, the phase array, what we now call radar, and so you can have either a dish that turns, or you can have a phase array that making the phase difference and all that, and making directed the beam, directed energy beam that shoots out. So that they could have done that. I mean, if it works, I mean, the reflection off the ground and all that stuff works. You can make it directional, and then charge the people accordingly. So I mean, yeah, that if Tesla said that, maybe JP Morgan wouldn't have pulled the funding.
So the problem was, you still should avoid sending power over the air because of the high amounts of attenuation in the atmosphere.
Yeah, that's true.
Radar and guided wave makes sense, but one of the things that made a lot of sense about what he said was, let's use the Earth, which is conductive. But to your point, actually against your point, I would say, look at electric vehicles. It took so long for electric vehicles to catch up, not because the tech wasn't there, not because the battery tech wasn't there, but because we had large commercial forces, the oil barons, the power companies, who didn't want to see it succeed. In fact, even governments have played their part in suppressing the rise of electric vehicles, because petrochemical industries are so popular. So maybe, by the way, about the directional beaming, there's a very interesting invention of Tesla's, which is misnomered the death ray. But essentially, it's a weapon that uses a gas chamber powered projectile, which is pushed by electrostatic force that can go up to 600 kilometers per hour at the enemy. And it's called the Tesla death ray, even though that wasn't what he called it. But it was a weapon that he invented. But to the point, communication radar, that's fine. We can do that. We still do that over the air. That works. The attenuation is not too much to lose a signal. But power transmission over the air is very difficult. We're just coming up with wireless charging today, right? And we can't do very far, because the further away from the charger, the less effective it is. We need it right on top of it. Our version of wireless charging today is that the charger is right underneath the device. Tesla was like, no, I can do it at a distance, but I need certain conditions, like the air should be more conductive than it usually is, like in Colorado Springs. But the ground, that was a very interesting proposition, because whenever we look at electric, in engineering, we learn that the earth is zero, it's ground, right? If you connect something to the earth, it eats away all your power and you're left with nothing. So don't touch the earth or use the earth for protection. But Tesla's like, no, the earth is not zero, it's It's infinite power. We just have to learn how to tap into it and create waves that can send this power from one point to the other, except the oil baron's got in his way. But I don't know, Hansen. Do you get my point? Like the difference. It's not.
No. I know. Yeah. So basically, it is the reason that we put it to the through the wire is because you confine the energy in the wire, and without leaking towards to outside. So I just wasn't sure how this is going to work. But I mean, going along with the flow. But the thing is, I may know what he's trying to do. Maybe that at a certain frequency, that the ground and also the atmosphere, the troposphere, would be a conductor at that particular frequency. So basically, you make the Earth a spherical shell waveguide, and so both ends are conductors, and so basically a spherical shell, and then so it could I mean the only way that to make it, because this shell, there's no other boundary that makes the confining the wave inside. You can only rely on the whole shell. So that's why I think maybe he's saying that you have to spread out all over the place, not unless you build a kind of another confining corridor for the electricity to transmit through. And so yeah, I mean, basically, I think he's trying to say that basically you have a spherical shell waveguide. But the thing is, so you need to have the frequency. I mean, the thing is, one thing is is there a frequency that actually makes the ground a conductor? And then also the second question is that frequency the same as the conducting frequency of the troposphere? Maybe the troposphere has a wide frequency range that can cover the whole thing, so that when you have one frequency, that it will not leak out from both up above and below. So yeah, I don't know. Has anybody actually done the research? Theoretical physicists done the calculation, anything to explore the feasibility of this scheme?
So, firstly, in terms of feasibility, he did many demonstrations in Colorado Springs where he placed light bulbs on the ground up to 600 meters away from his experimental magnifier, 600 meters. And he was able to make those light bulbs light up. And that is not a small feat, right? 600 meters of wireless transmission, we still cannot do today. Have no doubt in your mind, we still cannot do it today. Secondly, he believed that to achieve Earth-wide transmission, he would have to achieve the resonance frequency of the Earth. A very sensible but quite unattainable goal, because, I mean, it's a really large spherical conductor. It has a very large resonant frequency. We have to match that frequency, and the more we're able to match it, the more effective the transmission would be. So, once again, his experimental apparatus, which he only spent a couple of years working on, were able to achieve 600 meters, which is far beyond what we're able to achieve today. Although it was only enough to light up a light bulb, we don't know how much power went in, and therefore we don't know the efficiency. But theoretically, of course, very feasible, something we haven't theoretically gone past yet. Secondly, he wanted a prototype which had 30 towers placed across different points of the globe, and not necessarily on other sides, but essentially by the ultimate goal was to turn the entire Earth into a resonator that could transmit power. But the way that it could be achieved without going that far was a standing wave between the two resonating towers. Basically, the two towers are resonating the same frequency, which means that there's this sort of, in a way, it's when something is resonating at a certain frequency, it expects everything around it to also resonate at the same frequency. Whether it's air, whether it's earth, it tries to make the other particles achieve the same, match the same frequency because of mutual oscillation. Or it's just like, it's bumping into the surrounding particles, and the surrounding particles are bumped into the same frequency over and over again until they match frequency. So by doing this, if you have two distant points which are both oscillating the same frequency, eventually they cause the particles between them to begin to oscillate at closer and closer to the same frequency, and eventually there is a sort of line of resonance between them, a standing wave that occurs between the 2 points. And this one half of the standing wave could be underneath the ground, one half could be on the surface, but Tesla's invention focused on the surface and possibly the upper layer of the lowest layer of the atmosphere, which could be made conductive under certain conditions, like in Colorado Springs. But the ultimate goal was, if you tap into the resonance frequency of the Earth, you don't have to struggle to make the particles of the Earth resonate at the same frequency, because you're essentially resonating at the frequency that they're already resonating at. And so you're tapping into that inherent magnetic field, electric field resonance. And therefore, you don't have to spend power to make a standing wave. You're just tapping into the existing standing wave of the Earth. So that was the goal. I'm not sure what the Earth's resonant frequency is. I think it's something around 72 hertz when it comes into the air and into our brains. And that's an ambient resonant frequency of the Earth that we are accustomed to in our bodies. But I just have to look up what the Earth's resonant frequency is in terms of a conductive material standpoint.
Yeah, but the thing is, like I said, you can make find a frequency that makes the ground a conductor. But the thing is, the frequency, is it matching the atmospheric frequency that you have to make a reflection or standing wave above the instead of going off into space? And does that cover? Is the frequency resonance or the reflecting frequency of the atmosphere the same, or covering the frequency range spectrum of the Earth?
So that's very difficult for the atmosphere, because the densities of the atmosphere constantly vary with wind pressure and atmospheric conditions. It's not very homogeneous. Relative to that, the Earth, since the mass moves very predictably, like tectonic plate movements and things like that, it has a more stable resonance frequency. So from that perspective, and it doesn't vary so much, right? You might have a large mineral deposit, which changes the resonant frequency at that point, but largely somewhat homogeneous relative to the atmosphere. So from that perspective, it's easier to find a resonant frequency that works with the Earth than for the atmosphere, because there might be a cloud that completely changes their resonance, and you're no longer transmitting that.
Okay, so maybe you didn't get my point. I'm saying that in order to, maybe I'm not sure what the steam exactly is, whether it's just going through the Earth, or is it going through the atmosphere between the troposphere and the ground. If it is the latter, then you need to bound both the ground and the above atmosphere both ways. Otherwise, you're going to leak out into the space, right? So then if you have one frequency, the wave going out at one frequency, the one frequency has to be off the ground and the top. So the resonance frequency of the conducting frequency of the atmosphere, is it the spectrum? Is it when I say cover, meaning that if you have a ground frequency at 62 hertz, that's what I have no idea. But is the reflecting frequency of the atmosphere between, let's say, 50 and 100? Or is it 100 and 200? If it is the latter, we have no hope, right? So, or it could be the energy is going entirely through the ground. So I don't know which case is it. In which scenario is it?
So in the general case, you would avoid sending power over the air because of large attenuation. However, in Colorado Springs, in those specific conditions where it was on a hilltop and it was very close to thunderclouds, you had a large ionization of the air, which was conducive for sending power over the air. But generally, the air is not conducive for sending power. So the basis of the invention was to send it along the ground. The standing wave So the point you mentioned about it shooting past one end and has to bounce back, the assumption is that it's a standing wave, right? So you have fixed endpoints. So the energy.
So you're telling me, so that's why I'm asking the question, right? You're telling me that the wave is going through the ground, not in the atmosphere, right? Is that yes or no?
Yes, along the surface, I think was the invention, along the surface and maybe through the ground as well, but largely using the earth.
So why do you need
also
a
say,
tower?
Sorry, I'll also
why
say
do you
that.
need a tower?
I'll also say that if you take two Tesla coils, which are the same, right, resonant frequencies, you will get a standing wave of electricity between them, which looks like a large arc. So it's possible through the air as well, but just takes more electricity.
Okay. So just what's the optimal way? Just you're saying it's going through the ground. So my question is, so I kind of not quite understand. So why do you need the tower, high tower then?
So the optimal way would not be through the ground, but along the surface. Of course, a standing wave requires two directions, right? There has to be one going or one coming out, like whatever. So why do we need the tower? To achieve that resonant frequency, you need a magnetic amplifier resonator. So that there was this tower of rings, and those rings would magnify the frequency which you are aiming to put out, and they would act as the nodes of the standing wave. They would act as the points at which it would bounce back or reflect or transmit, right? So, and you need two towers at the same frequency. That's how you get a standing wave. You need them to sort of reinforce each other. If you have just one, it doesn't do much. So, I don't know if that makes sense, though.
I'm not sure. Okay, I have to look into the mechanism. So I just still don't.
Can I offer some insights?
Yeah, go ahead.
So in general, I think that it's a mistake to analyze Tesla's contributions in terms of wireless power. Tesla himself identified that wireless information and wireless power were both potential results of his 4-coil patent, which if you haven't read, you should read. Obviously, the largest impact Tesla had is in introducing radio communications, which I imagine all of us are using to have this conversation, which is pretty profound if you think about it. But I think it answers a lot of the questions that you're asking about relative frequencies and how frequencies interact in these places have been explored for ham radio, which is just a natural entailment of the patent. And bouncing signals off of water, off of the troposphere, ionosphere, has all been experimented such that signals have been propagated all the way around.
No, that's not the question. I've already stated that from the very beginning. I said the radio wave and radiation bounce off the ionosphere, and so that's the way. But Rajarshi said that was not the case. Okay,
well, there's one little helpful addition, which is that adjacent to water, which water is like the best example of the effect that he's describing. Next to water, these waves travel very well. If they're broadcast like from the shore, they'll travel to the other side of the water wave quite effectively. I feel like that is a kind of answer. I think you're also kind of looking for something more global, like the resonant frequency of the whole sphere as a spherical concept. I'm not even sure that's a thing because of the complexities involved, but it's fascinating, so please continue.
But so that's not the case, right? I mean, Rajarshi was just already said that it's not about making the Earth as a spherical shell waveguide. So it has nothing to do with the reflection of the water. He's already stated that it's transmitting through the ground.
Sorry. No, I think it's more accurate to say that it's using the Earth as a spherical resonator. I think it uses the surface of the Earth, not underground. Underground, again, you have more of the
surface. Okay, so the surface is the soil, the close to not the atmosphere, but the surface sphere. May not penetrate into the mantle, but you're saying that it's on the soil, let's say, soil surface, right? Is that your statement?
My belief and limited understanding of this would be to go after the most homogeneous surface, which would be not the soil layer itself, but the very top of the mantle, the topsoil layer, but just under the topsoil. Because here is where you would get the most homogeneous, and therefore you could accurately predict the resonance frequency and tap into that. So essentially, I'm saying that if whatever frequency you choose, it's going to resonate particles that are close to that resonance frequency. And therefore, the more homogeneous the layer along which you choose to transmit, the better your chances of success. That being said, Tesla's invention was looking at the average total resonance of the Earth, which means that you might be a little wasteful, but gradually everything will get there and approximate average out to there. So it would use largely the surface because the surface would be the shortest path. Simple reason, the surface would be the shortest path between those 2 points, and therefore the power would prefer that shortest path. So that's why the atmosphere is not so preferred, and that's why through the ground is not so preferred, because it's simply the shortest path. That being said, the shortest path might be through the Earth as well. If it was, for example, on the other sides of the globe, there the surface is not the shortest path, and maybe if the resonance frequency is right, it can travel through the globe also. But from my limited understanding, it was largely built to be along the surface of the Earth, guided by the spherical waveguide.
Okay, I don't know. Okay, I'll have to look into that.
I'd like to resonate with something Raj said, which was that if you have 2 Tesla coils, that they create a standing wave. Now, I built Tesla coils, and I one day just had 2 of them sitting next to each other, and I was operating one of them, and the other started behaving, and it wasn't powered, but it was of a similar build to the one that I was operating. And very clearly, it was producing, I say producing in this odd way, right? But the energy field around the second Tesla coil was much stronger than the energy as a consequence of the first Tesla coil. And the way I know this is because Tesla coils can light up a fluorescent bulb. Just if it's in proximity, the fluorescence inside the bulb will light up. Now this works, if you put it close to the Tesla coil. If it doesn't work, if you move it away by what Hansen mentioned, which is the square of the distance. So there's a natural zone around a single Tesla coil which can activate the fluorescent tube. But in the case of 2 Tesla coils, the Tesla coil was actually reacting. Well, I should say the fluorescent tube was reacting in the proximity of the second Tesla coil. Largely in the same way that it would have reacted near the Tesla coil that was powered. So clearly the second Tesla coil was actually in an energized state simply because of the resonance. And it's fairly anecdotal. I'm not suggesting that the rule of the square of the distance is, not between all of these resonant cases. But I have to say, anecdotally, there appeared to be something going on that was not what I expected, and very clearly not what one would get if one only had 1 Tesla coil. It definitely had a shape that was not simply the square of the distance, and that was because there was another Tesla coil resonant and present. So I just want to say, anecdotally, there's something here that deserves attention.
Well, I have to look at whatever your schema is, but mostly these are magnetic phenomena are resolved. Basically, the brute force way is just to solve the Maxwell's equation. So yeah, so whether you have to know what you're measuring, whether it's energy, the energy flux, or magnetic wave, and all that. So I don't think. there could be geometric factors, but you're saying that if you're saying that the power of the receiving end is greater than the generating end, that's impossible. I mean, I don't know. Maybe you're saying not over 1 over r squared, but 1 over r or something. But how do you measure that? I mean, you have to make a measure. You have to make
apparently greater than 1 over r squared.
Yeah, but did you actually make a measurement of the and measure the distance and all that, and then whether it's which is it in close proximity that when you measure r, which part do you start to make the measurement? Whether it's if the shape diameter is comparable to the distance diameter, then it depends on where you measure it. And then if you're far away, and I don't think if you do measure there could be that the coil, it's not the energy emanating could be not spherical, but if you're far away, and then if you don't have a special geometric shape that points concentrating power in one direction, you will get 1 over r squared. I mean, that's not a problem. But I mean, depending on where you how you measure how much distance relative to the geometric size it is, I mean, how you measure the distance would be a question. But if you're far away, the asymptotic law says that you have to be 1 over r squared. There's no, right? Unless you have a phase array, something like phase array radar that is directional.
Yeah. But what's missing in the equation is the impact of having a resonating receiver and how that receiver interacts with and shapes the field around it. And I don't know what that interaction is.
Well, I mean, so long as you don't have so long as you don't have a kind of another power, I seriously doubt that. I mean, you have to give me the schema, and then because there are a lot of when you sometimes people make statements, when they look into it, there's nothing other than just kind of not an accurate interpretation.
Yeah, I just want to say that, when we started this out, we have Hansen and Rishi and MJ as our co-moderators here, and it's a very good discussion, and perhaps we can make a topic about this. And I know that some people who came up on stage maybe would have come up because of some comments about what we are talking now on an unresolved scientific mystery, according to Rishi, as he said in the chat. And there are so many comments in the chat that we have here on the room now. But on the other hand, can we circle back to the topic, maybe process it a little bit, or probably make a new room about that on another day next week, so that we have time to contemplate, because I would like MJ to speak a little bit about what he prepared as an introduction here, because he is going to leave us in an hour from now. So I would like to give the chance to MJ, unless there is something very urgent for some people who came up to speak. So for now, I would like to give the floor to MJ, and let's plan our discussion about this, because I would like to hear our research and comments on what the Hansen and Rishi were trying to talk about, and Benjamin as well. So MJ, I would like to give you the floor now.
Thank you, Cecile. Wow, I mean, I'm enjoying myself so much just listening to Hansen and Rishi and Benjamin. All of those insights are exactly what someone like a Nikola Tesla would also just jump right in and I'm sure have his own 2 cents to say about, and if only he could, right? But my approach here is certainly not from this technical side. As I'm not a physicist, I'm not an electrical engineer. And I deeply respect anyone who pursues those fields as those present seem to with a depth of knowledge. My concern and my interest in Tesla comes as a creative, and I recognize in him the spark of a creative genius, and he was one of my first creative idols, even though my mediums were music and visual art. As a teenager, I recognized in his life, in his story, and in the movements of his mind, I saw, like, he's dealing with creativity. He's discovering things, but this is creativity at work in a field that is not traditionally thought of as, like, here's a creative genius in the field of engineering. So I respected him deeply for that reason first. So one of the things that I wanted to just get across, hopefully as a takeaway for listeners today, for two different kinds of listeners. For one, those who maybe haven't heard of Nikola Tesla, which those people still exist, certainly, and for those who already know him and his life's work, as is so clear with those speakers today already. So for those who haven't heard about Nikola Tesla, I'm hoping that we can impress on these listeners this truth that Nikola Tesla was one of the most remarkable and consequential human beings of recent modern history. And I think a lot of us that know his work or his story can agree to that. We can argue about that too, but then number two, for those who are already familiar with his life and work, my angle is slightly different. As a creative, like I said, as a writer and lecturer on these matters, I think that there's another valuable lesson that we can learn as those of us who already even understand some of his work. And it's that that with exceptional success in one domain often comes a sacrifice of another. And we see that in his life, because by the end of his life, he was penniless and living in a hotel and with no family. And his best, closest relationship was to a pigeon. And what is that? What is the paradox of someone who reaches these heights of genius but is lacking in some other facet of their life? And we have to respect that, both in ourselves and in those around us who we see who might be exceptional in certain facets of their life. So that's an approach that I take with Tesla, and I'll end my little part about a particular fascination with his creative process that we haven't covered yet, and which explains why we don't have all the answers about what he was envisioning with some of these projects that he didn't end up finishing, and why the FBI didn't get them either when they ransacked his hotel and looked through the safe for the papers, and all they could find instead of brilliant, well-thought-out notes were poems to a pigeon. It's because his creative process involved imagining and visualizing things with the greatest depth and sharpness, and this was something that people don't expect about him. So I'll just read this small passage from his autobiography called My Inventions, which everyone should read. So he says in this rather short paragraph, "My method is different. I do not rush into actual work. When I get an idea, I start at once building it up in my imagination. I change the construction, make improvements, and operate the device in my mind. It is absolutely immaterial to me whether I run my turbine in thought or test it in my shop. I even note if it is out of balance. There is no difference whatever. The results are the same. In this way, I am able to rapidly develop and perfect a conception without touching anything. When I have gone so far as to embody in the invention every possible improvement I can think of, and see no fault anywhere, I put it into concrete form, this final product of my brain. Invariably, my device works as I conceived that it should, and the experiment comes out exactly as I planned it. In 20 years, there has not been a single exception." Unquote. And that's where I'll stop for now.
MJ, I think you mentioned earlier on that his mother had an eidetic memory, and did Tesla as well? I didn't know there was hereditary.
Yeah, he has an eidetic memory. He is a polyglot, and he has an eidetic memory. So not only photographic, just they say, but it's actually eidetic. So because I'm having a dispute in my mind, and I would like to verify it, because there are some high IQ societies that I went into, and they are trying to claim that Tesla may have had an IQ of about 160 to 300, and I wanted to check, and verify how did they come up with that. Of course, it's aside from being a creative, I would like to check that out. But his mother had an eidetic memory, because she could memorize poems and so many things, even if she did not have formal schooling. So Tesla himself claims that he was following after his mother when he had this eidetic, born with an eidetic memory. And yeah, of course, he was speaking 8 languages. So I would like to also discuss that maybe in the future, because next week I plan to have a room about creative geniuses, because I would also like to announce that MJ will be having a room with us about the polymath Leonardo da Vinci and his life. And yeah, he has researched a lot about Leonardo da Vinci, and we will have it by next week. But maybe I would like to have a pre-party about what is a creative genius actually, opposed to somebody who has done a lot of achievements and a lot of honors in the schools that they have. And is very high IQ necessary to having that kind of creativity on that level? So anyway, back to your point, is that I also learned just maybe a month ago that Tesla is claimed to have had an eidetic memory. Thanks.
I can't remember who said this, but there was an anecdote from someone that worked with him that he used to do things like test out the wear on bearings for his devices by just simply running them in his head, which is insane.
Yep. Yeah, no, this is all true.
Yeah, I just want to say that maybe I don't have an eidetic memory, but like Tesla, but I do not necessarily take notes a lot. And sometimes when we have discussions here, there was another person who was a presenter, and he wanted to collaborate with me about some topic that we had. And he said I have to take 3 weeks because I have to take notes, unlike you who does not take notes. So, but I'm not as genius as Tesla, but I can relate, to what he feels if he has these experiments or designs running in his head to some extent. So maybe I'm a very poor, run-down version of Tesla in that case. But maybe it's my personality, or there are just people like that.
Yes, the crazy thing was that, we assume that someone of his level, that it comes easy to him because he accomplished so much. But in reality, he was the hardest working person you can possibly imagine. This was a man who, for a period of a year, would routinely only get 3 hours of sleep because he was working so hard in his lab. And it's documented and known that when he was working for Thomas Edison, by his own choice, by his own volition, he would work every day from 10 a.m. to 5 a.m. That was his work schedule. It's a 19-hour work schedule, and he was a force. And Thomas Edison greatly respected him for his work ethic, even though he, as was mentioned earlier, tricked him out of the equivalent of $50,000 after he had correctly repaired a problem with the DC generators. But the other aspect I wanted to mention that's strange about and noteworthy about this part of his mind and his creative impulse is that he wrote in this autobiography about this strange ability for his mind to visualize things incredibly clearly, and that initially when he was a child and it began happening, that it wasn't under his control. And so, of course, it kind of veers into these theories of potential schizophrenia and such like this. But what's strange is that he eventually developed the ability to control it, and he would on occasion say that it was realistic enough to him that he could reach out and feel like he could almost touch these things. And so that's really startling. And so I started to assume, well, let's look at his backstory, his childhood, and he did suffer many illnesses. There were a few close calls. So you can start to say, okay, maybe his wiring got a little fried from super high fevers and such. But then you learn that his older brother, who died in a tragic accident, and his parents were scarred forever from it. But he was stated that his brother also had the similar issue of these visualizations. And so, there's all these little elements that are just so deeply fascinating about him. And I don't know if anyone else can offer any thoughts on that.
Yeah, I think Rishi was flashing his mic a while ago. But what I would like to say about what you said about the visualizations that Tesla may have had seen, and as well as his brother, maybe we should check the kind of wiring that they have in their brain, because recent researches in neuroscience also, show why we are having these particular visions. And if you look at psychology, as the way the psychiatrists or clinical psychologists try to do some kinds of diagnosis. Sometimes people are diagnosed as with high-functioning autism or probably gifted. And on the other hand, with all these kinds of indications in my conversations also with those people diagnosed of that, they would say that there could be misdiagnosis, or they could be twice exceptional people, They could be like having Asperger's disease at the same time, and at the same time, they might be having schizophrenia. So, this is a very sensitive issue that has been investigated by those who are studying, creative geniuses, to say, or people who are twice exceptional. So I would like to maybe look at that a little deeply, as we see also, as we have brain imaging techniques and new researches in neuroscience as to what it has to say about the brain and the wiring of the brain for people who have those kinds of experiences. That's my comment. But anyway, there are more people now on stage. If you would like to speak, because you have been waiting for a long time, I give you a chance to speak, and the other moderators as well. We could always have another room, next week to continue the discussion, because I see now that Hansen and Rajarshi had given a new dimension to this discussion, because maybe if we break down what Nikola Tesla is, his inventions, his history, there are so many issues that happened in his life that, it's worth to discuss it bit by bit, and it will give us maybe more knowledge and lessons, just like what MJ was saying. He actually was sending me several questions that he is trying to address or had been addressing in his podcast. And any comments from the other moderators here or those people who came up to speak, please feel free to do so.
And maybe ask Raj or Hansen or someone what they thought of his ideas about the possibilities of longitudinal waves, or like electromagnetic longitudinal waves, which is supposed to not be possible. But he and also Steinmetz seem to think that they were, and actually were the cause of certain phenomenon that we have trouble explaining.
Okay, you just blew my mind. Can you please elaborate?
On the longitudinal stuff? Well, I mean, so with Tesla, they're sometimes called scalar waves, but I think that's kind of like a pet name for it. But this was when you were talking about the like the two Tesla coils and like the standing waves between the two. I thought that might have been what you were talking about, but I do know.
I'm sorry. Let me maybe I'll just clarify for the audience. All electromagnetic waves are traditionally not scalar. Scalar waves are different. Transverse waves. Transverse waves. Just to give you a picture, this will help to understand the difference. If you put your finger in front of your nose, just please try this. But if you put your finger in front of your nose, a transverse wave that's moving away from you would go left, right, but gradually making its way forward. But essentially, it's going left and right, primarily oscillating along the left and right direction, but maybe has a velocity moving away from your nose. But a longitudinal wave, it goes front and back towards your nose, forward and back towards your nose, forward and back towards your nose, but gradually more further away and less close to your nose as it moves along time, as it goes further along this direction. So as far as we know today, all electromagnetic waves are transverse waves, where the direction of oscillation is not on the same axis as the velocity. But you're just talking about an electromagnetic wave which could be longitudinal, and that just blew my mind. So I'd really like to know what sort of phenomena which are unexplained this could have explained, because I've never heard of this. Thanks.
I wish I knew more. That's kind of why I was asking, but I do know that Tesla was investigating this for the kind of line of sight based through the air electricity transmission. I think this also where he was trying to have some kind of sympathetic resonance between Tesla coils. I believe that's what he was using it for. And I think he was also messing around with communication, different types of communication methods than were being used by Marconi and all that. But Steinmetz was the guy that kind of more formally made a case for their existence. He was studying a phenomenon that was occurring with electrical systems at the time, where there would be these very violent arcs of electricity coming off of transformers, and the distance that they were traveling completely blew, and this still occurs, but the distance that these things were traveling completely blew away all of the formulas that one would expect to describe how far they'd be able to go, just based on the amount of current that was actually going into them. And I can't quite remember. I don't know if you know that. I don't know if you know Eric Dollard. He's kind of like this weird, mad scientist. I think he's completely crazy about 9/10 of the stuff he talks about. But this is one of the things that he kind of dug up from Steinmetz's writings was.
Okay. Sorry. Make a few clarifications. So one, electromagnetic waves are never going to be scalar waves. There are scalar waves that exist and that have been experimented. If you look at Tesla's designs, the Wardenclyffe Tower in particular, it was an acoustic resonance as well, which means it wasn't just looking to take advantage of the transverse waves and magnify those, the electromagnetic waves, but also to look at the sound waves within the tower and amplify those as well, because the longitudinal sound waves can act as carriers of electromagnetic waves. In fact, this sort of acoustic resonance with the electromagnetic waves is something that we've only caught on to very recently. That's how we're able to make 3D printers. The first 3D printers was stereolithography, which used acoustic waves to guide our lasers. And if you've heard of the Columbia, or the effect where people were getting health disturbances even from a distance, which they were claiming was a electromagnetic weapon of some sorts. Was it Havana effect or Cuban effect, whatever it was?
I know what you're talking about. Yeah.
Sorry, I might be digressing a bit, but that might very likely have been a combination of electromagnetic waves carried by acoustic waves. But essentially, as far as I'm aware, scalar waves, which include sound waves, electromagnetic waves cannot be scalar under any circumstance, but they can be carried by a longitudinal wave, which makes them more effective in terms of transference. And this is something that Tesla actively engaged with and experimented with. Aside from this, I think the reason you blew my mind is because I don't understand that I understand that it doesn't exist, or I don't believe that it exists. But that's this as far as I know. Take it with a pinch of salt.
Yeah, it's one of those things that every model says it shouldn't exist, but they're particularly from what I understand, the stuff that Steinmetz was talking about really hasn't been kind of concretely answered even today. But yeah.
Well, the thing is, I mean, we have to distinguish the waves in the vacuum and as opposed to waves in media. In vacuum, it is pure electromagnetic wave, but the wave in media is a composite of the incoming wave and the superposition of incoming wave and the reaction wave from the media. So if you have a linear response media, then yes, you're going to have the just transverse wave, because it's basically scalar and all that. But the thing is, if you have a nonlinear, well, actually not just nonlinear, it's just if it is nonlinear, more specifically, if you have a anisotropic media, then the story would be different, and you can have manipulations of the media to give you the composite wave being the longitudinal or kind of a skewed angle, or even completely parallel to the transmission, because the wave itself, the wave front itself, is a superposition of all those waves, and you can just do tricks on it. That's all possible, and so that way it's like saying that the particles can travel. Say, for example, particle can travel greater than the speed of light in media. It's not anti the special relativity. It's only because the composite wave is not traveling speed the same with the same speed of the particle, which generates a shock wave. And so yeah, I mean, you can do tricks on it to make a composite longitudinal wave.
I'd like to expand on that with a question. So I understand the abstract a bit. I had this theory after experimenting with an oscilloscope and a lucky bamboo plant on my kitchen table. And I found that it was pulsing at this radio wave frequency every so often on a timer. And it wasn't until later I found out, it is resonating with the weather Doppler. It's the Doppler radar. There's an airport not too far away that has its own weather station and a Doppler weather radio antenna. And the bamboo plant was vibrating to a harmonic of that because of the length of the segments that would harmonize with the waves that were coming through from the radio. So it's almost like it's a natural semiconductor. So I was wondering, if there was a way to do a bigger version of that experiment, not a bread tie around a bamboo plant, but like a wire around a palm tree, would we be able to use the mathematics and the radio acoustics of the weather Doppler radio antenna to listen to when the ping happens, and with the virtue of the echo inside the palm tree, how tall the palm tree is? Would we be able to use math to reverse engineer that with the acoustics alone? Is that...
So can you state the question? I was a little distracted.
Okay.
Can you state the question again?
Right. So in this diagram, we have a palm tree. We have a Doppler radar antenna blasting a ping of radio energy. And the palm tree is so tall. And the radio blast happens every so often. And
so your objective is to say you stand at a point, and objective is the palm tree is some distance away. Is that the idea?
Can you tell how tall the palm tree is based on the echo of that ping within the palm tree?
Within the palm tree, factor. Or you're a lot far away from the palm tree?
No, you're just okay. So you have a metal band around the base of the palm tree. This is connected to an oscilloscope. So this can read the radio wave energy that happens around the palm tree. And the water inside the palm tree is ionic. So it will respond to radio waves. The question is, if you hear a ping and an echo of that ping inside the palm tree, can you use the echo, acoustics, mathematics to determine the height of the palm tree based on the sound of the echo.
You mean like the frequency of the echo?
Yes, because there's going to be like a slight distortion, or like it'll go slightly lower or above pitch based on the dimensions.
Okay. Yeah, I mean, if I understand you correctly, but do you know the shape of the palm tree?
More or less. I know the diameter of the tree, and it's more or less uniform. And that's the length of the wire that's around the collar of the tree.
I mean, if you just look at the resonance frequency, no, you cannot.
Okay.
So if you
would have to transmit a sweep of a bandwidth of a certain width, and then you look for a spike at a resonant frequency, and that's how you would determine the height of the palm tree.
So if the height was the only variable, that would be possible. But I mean, the palm tree is constantly soaking up salts and changing its ionic composition. So if the height was the only theoretical variable, then sure, I think that makes sense. But otherwise, there's just too many factors.
Well, actually, it's more than that. I mean, basically, you're asking the question, Cash asked, can you hear the shape of the drum from the resonance frequency? The answer is no. No, you cannot. But you have to give more constraint on that.
All right. The resonance. Sorry to interrupt. The resonance frequency would give you a good understanding of the composition of what the drum is made of, and maybe even its approximate size. But if you wanted the actual shape and the physical form, then you would probably want to look at the reflected wave's shape, right? What is the shape of the reflected wave and how it bounced back, and therefore how long it traveled and bounced back.
No. You cannot, because actually, I mean, just make it simple. I mean, you have basically what it does is just you have a Laplace. I mean, the simplest way. I mean, of course, you can make it more complicated. Basically, you solve the eigenvalue problem with the Dirichlet boundary condition or von Neumann boundary or mixed boundary condition, whatever. The eigen value problem of the Laplace operator, and so the shape you can have infinite many shapes. Actually, you can make actually reflective shapes onto make basically infinite many reflective shapes onto it, and you get the exact same frequencies. And you can, though, the density of you can have a ratio of volume to the area. Actually, that's the Vigna vials or Vigna? I forgot. Vigna vials or Vigna theorem. Let me check. You can get the ratio of the hold on. I'll check it out. The frequency density is proportional to the ratio of the volume to the area. Something. I'll come back.
Can I pop in?
Yeah, go ahead.
I think it's my turn now.
Maybe Michael has been waiting for a long time. Sorry, maybe you can go after him.
Yeah, thanks, Rajaj. I just want to, okay, so I heard a lot of stuff today, but I'd like to first, before, I'd like to put some definitions first, because I think there's a lot of misunderstanding here. And I think the misunderstanding comes from really understanding what is electric current and what is EMF, electromagnetic waves. Because I don't think Tesla was thinking that, I can transmit electricity wireless. I don't think he was even thinking about that. He was talking about He was thinking about wireless communication. And only...
No. We've already covered that. The radiation is energy transfer. I mean, that you can, basically, we're saying that you're transmitting radio energy through whatever media, whether it's air or that. I mean, it doesn't have to be current. It's the energy transfer. So radio wave and
you have to talk about the energy.
Transfer, it's the same thing.
You have to talk about the energy. How much energy can you transmit in an EMF?
Yeah, I mean, that's the same thing.
It's
the same thing.
It's not the same thing.
It's the energy is the pointing vector. If you're transmitting through the vacuum, I mean, or actually media.
Okay.
It's the pointing vector that's the energy flux and momentum flux. So, yeah, it's the same thing.
No, it's not the same thing. Well, let me elaborate, because I think electric current, you don't understand what electric current is. You're mixing up electric current with EMF. Electric current is a sea of electrons that needs to go through a conductive material. This is the only way we can...
Sorry.
This is the only way we know how to transmit electricity.
By the way,
right?
No, we're not talking about. We're not talking about transmitting electricity, the electron per se. You only need to transmit the energy. That's what you want to transmit, not the electron itself.
Yeah, and in fact, this is the only way to transmit energy.
What engineering school did you go to, bro?
Hold up, Michael. No, please, you're out of line. Michael, you're out of line. Michael, hold up. No, Michael, hold up. You're out of line. He's a PhD, all right?
Did you guys study circuits at all?
Michael, hold up. He's a PhD in
circuits.
physics, all right?
This is
hold
insane.
Up. I'm an engineer, and let me explain. Do you know what Faraday's laws are? You can generate electricity.
Wow. Okay, go ahead.
All right,
ever use a golf cart charger? Because those things use an inductor coil.
Exactly. Inductor coils are one
wires
example.
Aren't exactly connected.
Yes.
But the electricity pulses anyway, just because.
Yeah, so you can convert energy from one form into electricity.
EMF is a byproduct. EMF is a byproduct of any electricity going through any conductor. You're gonna get an EMF.
That's fine.
He found when he had the coil. Let me just finish. He found that when he put electric current in a coil, he was like, oh my God, what is that emission coming from? What is that emission? And so he thought, oh my God, I could probably use that to transfer electricity. And a lot of people think that. I go to rooms and they're like, oh, the government took the FBI took Tesla's work because they're like, oh, they don't want to transmit electricity wirelessly. That's insane. The guy can never do that.
So we are not talking about transferring electricity.
I got 1 minute and I'll let you finish. The applications of his electromagnetic emission that he discovered is radio, is IR, is FM, UHF, VHF, all that stuff that we get, Wi-Fi, right? This is all EMF. But can you transmit kilowatt of joules through air? No, you can't.
The planet Earth's already doing it with piezoelectricity.
Yes, piezo.
We can't do it. We can't do it, bro. We can't do it. Prove that you can do it. Give me a paper.
Magnetosphere
that you can transmit
kilojoules,
and I'm here. I'll
protects us.
Bro, if you want to transmit energy across the air, and it doesn't have to be electricity, right? You're saying that all energy must be electricity for you to be able to transmit it. It's not.
Well, we're talking
you can
about
transmit
Tesla.
energy in other ways.
I'm not talking about anybody. I'm talking about Tesla. I'm talking specifically about Tesla. And I'm talking because you guys were saying, oh, you can transmit electricity through air, and that's just bullshit.
Not electricity.
Well, dude, if the atmosphere is a battery of electricity, like if you have ions of molecules in the atmosphere that are being charged by sunlight and like protecting us from all of those radiations that would kill us, like they're storing energy up there somewhere. Now, if you could find a way to wirelessly get that into a device that you want to use, that would be super. But that's like the mystery of the Tesla thing and the atmosphere and like the Earth as like a thing, because it's like you've got electrical ground, yeah. That's like the minus sign, the black part of a battery. And then you've got the plus side, And you've got the same thing with alternating current and ground that goes into the earth. But you don't really think of the earth as like a variable. It's not just ground current. It's like the pulse of the planet. And it's connected to this entire ecosphere. And it's got energy we don't know how to harvest yet. And for sustainable energy, that's going to be really important.
Okay,
it's a good mystery.
Yeah, I'm gonna take you back to circuits 1. And I'm just gonna define electric current, because electric current. This is where the problem is. Electric current hold on. Hold on.
Mike,
is a sea of electrons.
Okay. Hold on.
That needs to be.
Yeah. Hold on, Mike. Just a second.
I'm done.
Thank
you, guys.
So just a second. I think we may not be in disagreement.
Is that picture though?
We are. Hold on.
Is that there picture?
Michael.
So, Michael, I sense that you have a gap in your awareness, like your mental map of how electrons transform from one phase to another. Take us step by step through where your question is, and maybe there's a better metaphor that we can discuss.
Hold on, Paul. I just want to restate the statement here. So we're saying that Nikola Tesla was trying to transmit electric power from one point to the other, whichever way it would be. So, do you have an objection to that statement?
No, he was able to. He figured out. He found that if you have electric current, there is a byproduct. It's called. He called it EMF, electromagnetic. And we harnessed that. We worked on this, and we figured out we could get IR, we could get microwave, and that is electricity. Believe it or not.
Yeah, well, it's energy, right? Energy transmission.
It is. We're transmitting. It's a form of electricity.
Hold on.
In a very small energy.
Hold on. Just
one really quick point.
Eli, just a second. We're transmitting the energy from one point to the other. Nikola Tesla claimed he can do that. So, do you have an objection to that or not, Michael?
No.
Okay, so we're on the same boat then.
Well, we're on the same
boat.
There's
no more discussion.
But you can't say that you can transmit electricity.
Right? We're not saying transmitting electricity. We're transmitting electromagnetic energy from one point to the other. Do you have any objection or not?
We're already doing this, dude. Well,
I'm saying, do you have any objection to that statement? What's your point of coming to the stage? Do you have any objection or not?
No objection, but like when you're talking about like transmitting electricity between two.
No one said that.
No one said that. Okay.
Well, Josh, you said that.
No, I'm pretty sure I did.
We're done. We're done here.
Maybe it was my mistake, but let's continue.
You misheard. Okay, you misheard. All right, so we will move to the next thing. Eli, do you have any? You want to say something?
Yeah, I just wanted to make the point that infrared and microwaves, those are photons.
Well, everything, all electromagnetic wave are photons, just at different frequencies.
Yeah, but he said electricity earlier, so.
Yeah, I don't know. I mean, that he's mistaken. We never said that the transmitting electricity from, you can transmit electricity from one place to the other through wire, but the point here is to even the electricity itself. The purpose of doing electricity is not actually electricity. The electron. I mean, if we want to be more specific, it's not moving the electron. We are trying to move the energy, emitting energy and receiving energy. Okay, so that's clear. I hope it's clear enough.
Yeah, one of the best examples I can think of is a wireless cell phone charger.
Yeah.
So if you have one of those wireless charging
I mean, it
has a coil.
The thing is, it's just radiation. Okay. Everything comes down to Maxwell's equation. Just go solve the Maxwell's equation, and then you get the wave, and that is radiation, and we're done.
But Hanson,
getting to
I'm sorry,
vibration
Hanson, this is our last, and
you're not done.
My apologies. I hate to waste time because that's the most valuable thing.
I mean,
can we maybe reset the room? And regarding Nikola Tesla, I was just going to throw 2 points out there to the other gentleman. There is SETI that's doing, the frequencies and radio frequencies for, extraterrestrial life, or et cetera, and they're using that frequency. But regarding Tesla, which some people in this room know I'm obsessed with and have its notes and everything, we have to, I think we said it, so people are trying to go back to Nikola for the timeline he was in, and they're looking at it in my opinion, from a building stand. Someone has a hot mic.
Sorry, just to interrupt a little bit. I hope nobody actually kicked Michael off.
No, I think he said he was leaving.
I don't want. Oh, he
yeah,
did say.
Yeah, he said I'm leaving now. He just said something and he said I'm going. No, I don't think we don't do that. We don't do that in these rooms.
I'm fine with I'm fine with argument and debate and everything. Just get to the point. But I definitely don't want to kick people off either off the stage or out of the room unless he's unruly or something.
Yeah.
So yeah, but so he said he was leaving.
Yeah, and just so we're clear, okay. I know Sarah and Cecil. I mean, when the room first started, and it goes back a few years, so on Clubhouse. So we understand the respect, and everyone can debate and have theories. And you just be respectful and you figure it out. But yeah, I haven't seen them in a while, and sometimes I'm just getting too busy. But regarding Nikola Tesla specifically and building something out. The Earth itself has an iron core in it, similar to a meteorite, depending on where that, if it's 97% iron, I think it is, or Nikolai and so much nickel and so forth. And that's something that can have a magnetic resonance, which Tesla was working on. And sad to say, it was his death ray, which was interesting work that he was before the end of his life. As well as, and I don't want to diverge too much because I'm multitasking. Literally, I'm cooking again. But I'm stating, I'll just say some data points out there for the room to think about. Albert Einstein was working on a general unified field theory the last 10 years before his death. And Tesla was working on something similar, but not a unified field theory, just something to be able to, like you say, transfer energy. And if we deal with space, it's deeper, because a lot of us are looking at the Earth anyway in the Earth core. And my chairman is a former director of NASA who helped build the International Space Station, but program director, I should say. But when you're talking about transference of energy itself, we are working, or people collectively, scientific community, are working on figuring these things out so we can perfect them. And I would just admonish people when they're in these rooms, there's always a hypothesis in theories. Some can be practical, some can be realized. Sometimes they're not. But we also have to remember that the internet didn't start in 95. It started in the 60s by DARPA. Well, actually ARPA, that became DARPA. And then the World Wide Web came in 95, circa actually 94. So when we see all of this development, we can back reverse engineer it. But sometimes we have to know the history to know where we are, to know where we're going. And I would just say, I think the gentleman speaking earlier is building off the knowledge he understands and what he's been taught. But, and if you talk about Tesla was doing a lot of things. I mean, there's volumes on them that certain people have and they don't. And so, is it perfected? I mean, Leonardo da Vinci did some of that. But what he was talking about of transfers, and I agree with you, Anson, it was always to transfer energy itself. Because everything is energy. And that's what the atoms are, and that's what we are. We're all energy. And if you can figure out a way, you don't necessarily need the basics of transforming. In a sense, are humans conductors? We can always say that, right? So it's how do you rub your feet on carpet and you get a little shock when you're 6 years old or 5 years old and you play with your friends. Is this entire universe an energy universe, an electric universe, or is it not? Or is it just dead matter? And I think that question is more, of a philosophical question than anything else, because that sets the premise on how people view the world, in my opinion, or the universe itself. Is it electromagnetic, in of itself, pure energy, and energy is moving all the time, always fluctuating, like the Earth is always rotating, or is it static and dead? And things need to be, you only have a certain conductor at certain times. And that viewpoint, I think, will help enlighten a lot of people, depending on how you view it. Because if you view it one way, it can't be done. If you view it another way, it can be done. And we have already proven that, because now we're building space shuttles and we're going out to moons and Jupiter and Mars. And 100 years ago, this wasn't even thought of, right? Or 150 years ago. It wasn't even imaginable, because they hadn't seen anything like it but horse and wagon. If we go back 200 years ago, nothing for 4,000 years, the Earth had never seen anything, so it was unimaginable. So that's all. I'll let my plane that way.
I'd just like to add on the point of the philosophy of the universe and what Tesla's own thoughts on this were. He was actually inspired by ancient Vedic philosophy, and I'll just quote him: "All perceptible matter comes from a primary substance or tenuity beyond conception, filling all space, the akasha or luminiferous ether, which is acted upon by the life-giving prana or creative force, calling into existence in never-ending cycles all things and phenomena." He studied the ancient Indian texts on philosophy, and he was inspired by them. He spoke to the forefront Swami Vivekananda, who was the most famous spiritual leader of the time from Hindu philosophy. And this was actually, he firmly believed in this axiom of physics that the Vedic tradition puts forward, that there is a ether-like substance and the entire universe has a all-pervading life force. The universe is alive and a life form of its own, and that this all-pervading life force was actually the root cause of all physical manifestation and matter. He wrote a lot about this, especially in his later days, in his journals and his notes. I just wanted to bring that up, maybe some of his spiritual side and what he thought about the philosophy.
Well, and I would add to that, and you said ether. We call it in the U.S., or my accent, ether. But you're correct. I didn't even want to go that far, but I agree with you wholeheartedly. And I've actually spent time in Tibet. I've been to a monastery. I've done that. And I've traveled. And when you see the world macroly for humanity and the earth itself, not the world we live in, but the world of civilizations that you live during a time period, and then the earth itself. And then you go outside of the earth. If you go to space, if you're lucky enough, or whatever, you could understand that there's something way beyond what the five senses perceive. But yeah, Tesla did believe in the ether. We call it the ether, or this all-pervading energies. We would probably now scientifically call it atoms, right? Because we know that atoms are everywhere. And if you're splitting an atom and so forth, and we talk about the work at CERN over in Switzerland and France, and what they're doing with their accelerator, their hyperconjugal accelerator. I'm tired already. But if you look at CERN's work and what other work is being done globally from pure science, you'll see sort of a correlation of what's coming or what we have. And this is CERN's work was, trying to see if we could split atoms or measure what happens when atoms smash. Do we get antimatter? What is our work we're working on this particle accelerator? And that's what it is. And so people forget about this. I just think you need to add all these variables up to understand your worldview. Everyone, and I think they should all consider it. All of us, we can't weigh one thing against the other, because that's the human tapestry. We must weigh everything and weigh it well, and then test, verify. And just because something can't be proven today in a actualization of metaphysical form, it can be proven tomorrow. And that doesn't mean the theory was wrong. You just have to weigh it out and see what's going on, in my opinion.
Absolutely. And I'd just like to quickly add that someone mentioned about scalar and longitudinal waves. And I think in my very, very limited perspective, I think that ether could be vacuum, or the 0-point energy that we slowly coming to understand has almost infinite potential. But someone brought up the longitudinal waves and scalar waves. That's relevant because Tesla was already manipulating or attempting to manipulate this 0-point energy, which we're just discovering, which is like, beyond the atomic scale, way, way smaller than the atomic scale. And he was essentially trying to tap into some of that as well in the acoustic resonances of his machines, of his generators and amplifiers. That's just what I wanted to mention. Sorry.
So you're telling me that spiritual energy is just around the corner from material energy with sound and light somewhere in the middle.
Well, it's frequency domain.
All right. So if the frequency domain can be bent around like a bendy straw into different metamaterials that we can have in an online shopping gallery,
you have to create.
Like, what can we do? We have like. I mean, we have stained glass windows, and those are beautiful, and that's a metamaterial. I'm sure we could come up with some multi-dimensional something or other. Just saying.
So, Paul, just to answer your previous question, that I was trying to recall whether it's Weil or Wigner. It's Weil's law, and it says that the number of eigenvalues is proportional to the volume of this volume, and then also the number of eigenvalues less than, let's say, lambda is proportional to the volume, and then proportional to lambda to the dimension divided by 2 power. Okay, so if you know the similarity shape, you can count, you can approximate the volume, but if you don't know the shape, you're out of luck.
Okay, what if we have a general shape profile? Like, I know that a palm tree is vaguely conic. It is a bit narrower at the top, and it's a bit wider at the base, and we have, like, I don't know, we might be able to get an antenna wire to go from the base to the tip.
The problem is it doesn't stop at the base. There's roots, and there's the ground, and it's all connected.
Right. So I know that the roots and the ground have their own semiconductor network through the fungal network, and that's like the Earth crust original internet 1.0. But, like, I'm still trying to figure out, like, here's a basic thing. Is there a way that we can improve palm trees growing just by changing the timing of the Doppler radar spinny antenna thingy? Because the timing of it might be better or worse for plant growth, but we don't know what to rely on.
If I could jump in real quickly, and Paul, just quickly, it's always vibration. And all animal life or mammal organic life or plant life, in my research and what I've known to be true and opinion, and I'm specifically in AI and focus on AGI. I'm not a botanist, but it works on vibrational frequency.
Okay.
And so you're just thinking, see, when you look at everything, even the planet itself has grid lines. This Earth has grid lines. So everything is a vibration if you really could measure it, because that's why the Earth rotates. I mean, I always wonder when I was young, why isn't it just stagnant? And why isn't it stagnant and we just rotate around the sun? And I'm not talking about, I know Galileo and all of that, but why does the Earth need to rotate? Why does it need to move? In of itself, just why? Because I'm always that person, who, what, why, when, where, how. Always those 6 data points, and I just keep going, and I don't stop. Okay, so it's just my brain, but why isn't the Earth stagnant and we just rotate once? So something on this planet is sending a vibration back to the universe as we are our own galaxy. See, this is something that scientists know, or at least those in space or who deal with that, they understand that. Because, if you just really think about it, just pure logic, just objectively, right, as a hypothesis, for this to rotate in of itself, why does it rotate? Why does it need to? Why is it just...
But the thing is, unless you're asking about the very first condition, that's if we just confine it ourselves to even, Newton's classical physics.
But even before Newton, Hansen, I can go way back. You're right. I'm not talking about scientists who we build on, because I am one who, you're right, and we go by what they've said or what they've discovered or what they experienced. But just even asking ourselves, because I think that's what Paul was postulating, you just ask yourself, why does it rotate without the gravity? Without, let's say we are aliens and we came from another, universe or galaxy or something, right? Like multiverse, whatever. And we came here and we were like, well, so why is this planet rotating? Why do the 7 planets rotate, right? So I'm saying,
why is this apartment slanted?
Yeah. Well, so there's a reverse engineering or reverse process one can go through. I'm saying there has to be, regardless of the cause, there's also has to be a reason why that we, in our current state, may not understand yet. Maybe some minds in history have discovered it, and maybe they didn't. But it's why is this thing doing what it's doing? And just because one doesn't understand something, like me, including me, let me be clear, doesn't mean I have the answer. I don't know why it's still, even to this day. And I won't accept any answer because that's just me from anyone. I won't accept any theory.
No, hold on. I mean, it is a very big question, but would you accept the answer that, say, for example, the why is Earth rotating? Because at the primordial galaxy, that when it coalesces onto the sun, and then so you have the angular momentum that it's carried in the particles, and then when they coalesce, it inherits the angular momentum, and then you have the conservation of angular momentum. So that's why it's spinning, and why it's spinning in the same direction. Most of the planets are spinning in the same direction as the sun, and the orbital direction. Would that satisfy you?
To some extent, and I won't take this deeper. Oh, I'm sorry. I'm just going to land my plane here. To some extent, but even the sun's gravitational pull in this area starts making me question. But I do think it's just my point I was suggesting and confirming is that there is a vibration going on, because movement is vibration in of itself. That's just observable. And any movement's a vibration, and it has a frequency to that vibration. Whether we have the instruments to measure it or not, or some do, some don't. But any movement is a vibration, and that has a frequency node to it. I'll call it a node or a signature. And when something can move, then you're talking about going back to the Buddha plan he was talking about, or so to speak. Everything has a vibration, and animal life will vibrate on a certain frequency. And there's been studies on this in labs and in sort of green rooms, which shocked me. Like, they can have tremendous worse weather, okay, like storms, tornadoes, or whatever, in the lab. I'm talking about plant life. And then give them some music, and I'm not joking, I've seen it. And then they start coming back to life with some sunlight. And I'm thinking, wait, this doesn't make any sense scientifically. But they're resonating with something that's outside of the circumstances, or, the current environment, I should say, at that time. I mean, if it kept going, of course, it'll kill the plants. But if it's just a bad weather storm, so to speak, simulated, then you see something else. And I'm going to land, because I don't want to interrupt anyone. I just wanted to add to the test, and I'm trying to cook and listen. But you're right. I hate when the other gentleman, I shouldn't say I hate it, but when he was too, and Hanson, you were doing a great job, when he was too aggressive about one point or the other. Because I think we're all here to learn from each other and share ideas and postulate. And I don't believe in dogma. I believe in learning. That's just me. And knowledge is that way. And so we share, we respect each other, and we understand. And so I need to shut up and listen and learn.
So to what Paul was asking, I just want to say, specifically, you can you can change and alter those frequencies. However, that's what farming is. And I think it's funny because everything that we change within this system is basically read out through the system, because in order once you basically input something into this system, you get feedback. So every other card falls a little bit differently, and the light is just a little bit different. So if that makes sense. But to what Paul was saying, yes.
Yeah, it does. I just wanted to talk about how playing music to your plants could help them, according to some studies, but a little subjective, and Paul seems to have left. So let's just not leave anyone out of the room. I mean, there's people who've been waiting for a while, maybe Jocelyn or Neil.
Yeah, but can we concentrate on Tesla?
Yes, I would like to go back to Tesla.
Yeah, I agree with Hansen here. I think that Tesla was a person who did experiments and made observations. Now, I have done personal experiments with Tesla coils, and I have shared my observations. And it is possible to encourage other people who claim to be scientists to share their observations. I think it'd be nice to limit it to that.
Hello, this is Neil King. I would like to make some comments about the Tesla question. I think the last time I was resonating very clearly to any theme being discussed was about half an hour ago when I think Hansen was talking about some issues. So I would like to go back to that for just a few seconds. 2 points. One is that one thing I'm never sure of when I listen to people talk about Tesla is how much they're talking about electromagnetic phenomena and how much they're talking about what could be plasma phenomena, which may not have been I think people were not well aware of at the time of Tesla. So that may be, for people who are interested in trying to understand what he was doing, he conceived, and I am not, frankly, it seems like it'd be an interesting exercise to consider whether some of the things he was looking at may have been complicated by the plasma physics, which involves all kinds of waves, magnetic, electromagnetic, gas, ions going at all angles. They're quite complicated. Mostly the theory has been developed in connection with attempts to develop fusion reactors, but there's quite a bit of atmospheric study of plasmas as well. So I wonder, in other words, whether or not Tesla may have been stumbling upon some phenomena there that he interpreted in a way that has not worked out. At least it has not worked out so far. That's one comment. A second comment,
Sorry, can I just make a quick note there? You may.
Stop interrupting him, please.
I'm so sorry.
What?
I didn't mean to. If that's okay with you, Neil.
Why are we interrupting him?
I'm sorry.
I'm sorry. You're confusing me.
I'm so sorry.
Let's maybe not interrupt.
I asked permission.
Maybe there's a latency here that everyone is speaking all at the same time. So I'm sorry. Sometimes if you're in another place, there is latency. And sometimes I find myself interrupting other people because maybe I did not hear them speaking. So let's set order for a while now. And who is going to speak?
I would like to continue my point, please.
Sorry, Neil. Please go ahead. Sorry.
Okay. So the first point was then that someone like Hansen, some of the questions that Hansen raised may be related to being the fact that there could be plasma physics issues as well as electromagnetic issues regarding phenomena in the upper atmospheres. That's point one. The second point has to do with the comments that or the discussion that Hansen was mostly leading regarding the power of the power dependence of the power of such radiation as it propagates through the atmosphere. And I would like to point out there that in the case of radiation spreading out over the surface of the Earth, you actually do not have a three-dimensional. You're not expanding.
No, actually, I was just about to make that point. Okay, so that's.
Wait, can I continue?
Handsome, let him finish.
Because I was.
Let him finish.
Yeah, no.
I'm sorry. I can't. It totally confuses me when you jump in on my.
Yeah, but I was about to make that point earlier, but I was just waiting because the topic.
Okay, you can let him finish.
Is it Hansen?
Yeah. It's
okay.
I
feel a little better about that. Okay. Yeah. Well, all right. Well, I was going to be a little bit more specific. So that basically.
No. I know. So let me because you're responding to my statement earlier. So let me make addition to
okay.
that.
Can I make a reservation comment on your response?
Yeah, sure. Definitely.
Okay, so then I'll let you proceed.
Yeah, no, I know where, because I was about to, wanted to say that the earlier, because but the topic will meander to something else. So yeah, I mean the thing is, the whole thing is about the principle is the conservation of energy. So the propagation, whether it's 1/r², 1/r cube, or whatnot, it depends on the geometry you're conducting. So in the atmosphere, if we are spherical symmetric, then it's 1/r² because it's surface. But if when you go out into a larger radius, into the let's say between the atmosphere and the like I said before, the if you have a spherical shell, and then when you go at a larger distance, comparable to the distance between the height of the atmosphere between the ground and the atmosphere reflecting layer, then because it's not reflecting off of the vertically, so it's confined in the Earth sphere, Earth surface. So it's 1/r, but that doesn't explain. Let me be completely clear. When Benjamin was doing the experiment, I do not believe these two test coils are let's say 100 kilometers apart. That's within the the dissipation is still 1/r when you going away from the source to the distance that is comparable to the height of the atmosphere. So the Benjamin's the description of the coil is within that distance. So when you reach that, after you have reached that height and then continue to propagate, then you get 1/r² law. And that is not even completely true, because that's assuming the symmetry, spherical or the radial symmetry of the wave. And if you have the phase array source radar that or even a kind of a dish that beam the energy in a certain direction, that's not true. And you can see that in a wire, in the concentric, I mean, in a waveguide, the same diameter, then it is not dissipating. Not considering the material absorption. If we're not considering the material absorption, yeah, I mean, but that doesn't apply to my previous comment on Benjamin's experiment. So my previous comment on Benjamin's experiment still holds. And also that is also 1/r². That's not considering the density or the rounds of the coil itself. I mean, if you have an open coil that is not tightly wound and not like the length of it is, the height of it is not high, the efficiency is way lower than 1/r². Okay, so I think that's what Neil is trying to say, right, Neil?
Okay, it's part of what I've been saying, but I have further information that would be useful to you if you want to follow this up in more detail. One is that regarding the spreading out, the power reduction with distance, I would consider not to think about the 150 or whatever kilometers that you were talking about in the height of the atmosphere, but rather that people have studied this question regarding the propagation, how the power is reduced with propagation distance, very much in the context of cellular radios. I mean, cell phones, basic cell phone antennas, and they do see that there is what's called a surface wave effect, whereby the infrared, I mean the radio waves stay preferentially closer to the surface than you would expect, and so the power attenuates more like 1 over r than 1 over r squared, with an exponent I forget. It depends a little bit on whether there are trees or whether there are lots of trees or whether there's grass or if it's desert. These all make a difference. They have different effects on the absorption, I suppose. But so that's kind of a pragmatic issue that people study for very obvious reasons. They want to know how far close they have to space their antennas to make cell phones, carry to get this network to work. Related on a different angle, there are studies on or calculations done on surface wave effects by the physicist Sommerfeld, who was the great teacher of quantum mechanics in Munich in the early half of the 20th century. He also gave lectures on various aspects of physics as a professor, and one of them was on the electromagnetic radiation. He had two that are relevant. One was on electromagnetic radiation, and one was in partial differential equations. And in one of those two, he does calculations of the surface wave phenomena. So I remember that being sort of vaguely interesting. Anyway, this is just for your information. I'm not sure you want to get into this, but I probably won't. So I won't. I don't really have any further comment to make.
I think that's a great thing that to know. I suppose I don't know about the surface wave effect, but I mean, just make sure that previously the Tesla coil that Benjamin was referring to is between like a tabletop thing, so that doesn't apply. But I just want to make sure that the surface wave, it could be because the let's say the media, is it surface as in the atmosphere, or the soil under kind of subterranean?
I think it's surface. It's the surface of the ground. Basically, what I think, one way probably of thinking about it is that the radio waves are propagating in all directions to start with, but they find themselves. Here's probably what's going on. When they propagate into trees, for example, in effect they're slowed down. But if they're slowed down at the tree level, but not slowed down just above that, then the speed of the waves will be a little bit higher just above the tree level than they are on the tree level, so that basically the waves will be turned downwards.
Sure. Yeah. I mean, that's just a Snell's effect. Yeah.
Yeah. So when it's turned downwards, it's kept close. It's moving close. In the plane, in effect, just above the tree level. So that's again that's a two-dimensional. It's two-dimensional spreading only instead of three-dimensional spreading.
I'm sorry to interrupt. I have to.
It must be like reflected upward from the ground again, and then. So is it basically? I mean, is it because the let's say the humidity of the atmosphere that affects the speed of transmission?
I think in this case it's not the humidity, because that humidity would not be that different. I think between the trees and just above the trees. But I think just the stuff that's just slowing. I mean, just it's producing in effect an index of refraction for the radio waves.
Yeah. But what I'm saying is, I'm asking why the index of refraction is coming from the epsilon square root of epsilon times mu, right? So you have electrosusceptibility and then the magnetic permeability. So what made them change? Is it humidity or something else?
I think it's probably the trees.
It just so if I cut the trees down, if I just going through the, let's say, concrete, would I have the same effect?
No, I don't think so.
So basically, you're saying.
I mean, basically the. I don't.
Do you mind if I jump in here for a second? The effect that changes them there, it's the same. It's a ground effect, so it's the same as if it were a sound wave in a channel. Basically, you're getting the wave will. the trees will make the wave diffuse, but the effect of it speeding up or increasing in amplitude closer to the surface is from the phasing, the phase cancellation and phase amplification.
I understand. But the thing is, okay, if it is a sound wave, it's different because the sound travels when it close to the ground. There's a sharing. There's the wave, the molecules on the ground because of friction. The wave propagation is slowed down, and then upward is the faster, and then the weather condition affects it too, because let's say you're dead of winter, or like a winter, you have you also affects the speed of the sound acoustic wave in the media. So that's why sometimes like the winter in foggy weather, you can hear let's say much further because the wave can bounce back and forth on the surface. But this is the first time I heard the ground effect on the magnetic electromagnetic wave, and Neo is saying that it's all due to the trees. This is even more surprising.
I think it's due to the trees. I mean, this comes from books that I no longer have, unfortunately, on cell phone engineering. People who have, basically studied this problem from the point of view of trying to get the most effective use out of their cell phone networks, antennas. And so I was really, it makes a little more sense to me when I think about it. If you remember Feynman's explanation of index of refraction, why is it that electromagnetic radiation appears to travel more slowly than speed c when it's passing through a medium? And what he points out basically is that it's not really that the basic radiation, the basic electromagnetic signals are traveling slower than the speed of light, but what's happening is that the waves are driving the atoms in the material.
Yeah, of course. I mean,
and they're causing a phase lag.
I know. It's a superposition. Yeah, but the thing is, I mean, my question is, why is it why is the effect? I mean, the index of refraction, or which is basically the electro susceptibility times the magnetic permeability. Why are they affected by this distance to the ground? And also, you're saying it's not even distance to the ground, but trees. And I asked you whether if I do the concrete, it's different. We know the principle. But the principle itself does not distinguish between the concrete and the trees. So that's the question. Not.
Well, if the concrete was shaped like trees, I think it would have a similar effect.
Well, I think that it's a material. Okay, probably maybe trees is over specification. But for example, I would imagine that there would be more similarity between trees and, for example, metal pipes, because in the case of the metal pipe and in the trees, you have some conductance, some conductance along these objects. Where if you put concrete, I think the conductance would be less.
So you're saying it's water? I mean, it's water or the wood? I mean,
in the trees, I think it might be the water, the sap. Yeah. In the metal pipe, of course, it would be the metal conductance.
Yeah. So it's conductivity, right? The mu and epsilon.
Well,
anyway,
matter density really matters. It's not that it travels less than the speed of sound. It's that or speed of light. It's that the speed of light is lower in a medium.
Well,
the speed of light is only
it's lower in the media. The question is not whether it's lower in the media or not. It's how which media. I mean, because obviously it is the Snell's law, but why is it higher? Why is the index of refraction higher to ground, closer to the ground than away from the ground. I mean, that's the question. Not it's we all know it's greater than 1. I mean, yeah, but
well, okay,
why is it
the
difference?
The explanation that Feynman gives for that, which he does with detailed calculation, of course, is you could imagine first you have empty space, and you're propagating the wave through the empty space, and it travels at speed c with no complications. Now put one atom inside in the space. This. Oh
no. Okay, so you're trying to explain why it's slowed down, right? Is that what you're saying?
Yeah, basically.
No.
Point.
That's not. You didn't hear my question. My question is: we know it is slowing down, but why is the gradient? Why is there a gradient from the height 0 to height positive? Okay, and then it's the smaller the height is, the greater the n is. I mean, that's the question. Not why it's greater than 0. We all know it's greater than 0, but why is it decreasing? Why is it a decreasing function as a height?
Okay, I claim that it's not a decreasing function of height. I mean, basically, that I would claim that, or propose that the effective index of refraction for the radio waves is lower within the trees, but more or less controlled by the density of the trees, and then it would drop. Then this density drops off, of course, once you run out of tree. When you go up high enough to drop the trees. So then I would say basically there's two regions, two vertical divisions. In the upper division, above the trees, the index of refraction is about 1, and then below, before the level of the trees, and below the tree level, the treetop level, then the index of refraction is higher than 1, because of the contribution of the trees or pipes or whatever you got there that scatter.
So basically, it has nothing to do with the trees, right? You're saying that if I have a rough ground, let's say, just like a let's say shanty town full of buildings and the concrete buildings or whatever, maybe the metal may not be a good tin roof, may not be a good media, but maybe let's say full of concrete and jagged rough terrain. Would you have the same result?
Well, I'm not really sure. I mean, my instinct would be to assume that the trees and the sap in the trees and the conductivity in the metal would be more similar. But I don't know if anybody's really looked to do that specifically. I know that they did it with trees because they were interested in covering ground that had trees in it. So that was a specific feature of their test. I don't think anybody went to try this in a field of metal pipes.
It's well established that trees will absorb radio frequencies.
Okay, that's probably a good reason to assume that. Well, how would they compare with yeah, okay, so that's probably that's true. That's probably reasonable.
But then if it is absorbing, that's a different story, right? I mean, if it is absorbing, then that means you're dissipating the energy. That's not good, right?
Well, it depends on what you want. I mean,
it's not good.
But anyway, they found that. I mean, it was not reported to me in the context of good or bad. It was reported in the context of what does it do to the exponent of the decay of the power of the radio waves. That's what they were interested in.
I should clarify the notion that it's not good, because we're using radio frequencies to communicate, and if they collide with each other, that creates problems, right?
No.
There are some benefits of existing in a radio absorber.
They go through. They don't. I mean, it's not collapsing.
Waves going to interact.
Yeah, I mean, it's superposition, linear superposition. They just go through
linear
each other.
Superposition or not, if you're operating in a frequency in the same range as somebody else who's operating on the same frequency, you're going to have some challenges.
Oh, no, I mean, just superposition. That's all there is.
That's a different issue. That's a really different issue.
That's a different issue. Okay, and if the trees absorb the energy, that means that it's not gonna be like 1 over r squared. It's exponentially decaying. you're not getting signals.
But that's the point. Apparently, in this context, the absorption as such was not as significant, at least over that range, as the tendency to as the propagation exponent being reduced from 2.
But okay, so yeah, I mean, that's
1.
all. I mean, that's not the thing. Is that whether trees is a good absorber, right? I mean, if it is not, then everything's good.
Yeah, I don't. I mean, my conclusion
good.
would be that it's not really a great absorber, but it is a good. It does affect the phase of. Well, it does produce secondary waves, reflections, which cause a net slowdown in an effective index of refraction for the radio waves at the level of the trees and below, between the trees and the ground. That's all I can really say, because that's all that I remember from the books that discuss this sort of cell phone antenna design problem.
That's cool. Yeah.
If you check chat there, Neil, I wrote a brief little description of like it's handy to think of light as photons. You can easier to wrap your head around its absorption and emission spectrum within the confines of the atom, the electron energy orbitals. Right, they're all because there's a minimum scale of the universe. The Planck length. All the available emission or absorption spectrum or the absorption frequencies available from an electron have to be an integer multiple of the Planck length. So because the minimum scale, that one photon that is technically that would be individual light quantum, right? So it has to be able to go divide into the frequency. That's at an integer multiple, which is why photons can only exist or electrons can only exist at certain specific energy levels. They can't exist in between because it's not an even multiple thing. So.
Well, actually, I mean, the energy of photon for practical purposes, I mean, the frequency for all practical purposes, it is a continuum. I mean, it is because the energy of each photon is h bar omega, and omega is for all practical purposes is a continuum. But of course, I mean, it's not at the same frequency. You can only have integer amount of them. It's two different things.
Yeah, and I
think about the energy level of the photon as far as its oscillation frequency. So the way light right from radio up to gamma it's still just the same photon. So, but that photon can be energetic to from radio. Its wavelength, its oscillations over time can be high frequency or low frequency, right up to gamma down to radio waves. So, but that frequency is what determines whether or not that electron can absorb it. If that frequency is evenly divisible, right, by the corresponding atom, right? So its wavelength has to be if it's at 432 or whatever, if it's
I mean if to be absorbed and emitted by an atom, then you have to be fit into the difference in the orbit frequency or energy. Yeah, that's not wrong. I mean I'm just saying that the frequency itself can be anything. I mean, if it is not fitting into the the energy difference, orbital difference, then it's not going to be absorbed. Yeah.
And I would add, Hanson, maybe, so the metaphor was what? A tree and, we're talking about a cement block, if I'm correct, right? Because I was multitasking. Or something made of cement, was that correct?
Sorry?
Oh, because my brain's going all the way back to the beginning. When we're talking about absorption of frequency in atoms and growth, we were talking about, I think it was Neil speaking. He was talking about a tree, and I'm not sure if it were you or someone else because I was looking at my phone. They were talking about if it were made of cement or another material.
Oh, I said if you replace the tree with cement, would you have either the shape of a tree or not the shape of a tree? Would that make a difference?
Right. Okay.
Or
So yeah,
just
that's
cut
what,
down the tree.
Right. That's what I was stuck on because I was thinking of the height and the proximity to the Earth itself. You're right, and what's underground, and it intrigued me because I was thinking if we simulated something that was not a natural tree. Okay, so we know natural trees like the red forest, and these trees grow really, they live for 800 years or thousands of years. Well, we'll say several hundred years, longer than humans, and they're able to, grow this organic life, especially like at Stanford, right? Like you have all these trees up there. So, but what if we created something that was a hybrid of the material of a tree that could absorb light and sort of nutrients, but that would be synthetic, man-made material, versus a cement block. That's where my brain just stopped.
Well, Tesla is really getting lost here.
Well, no, Tesla was working on something like that, so I'll get to that in a different point, because he was working on a lot of things. But if you can create something, I'm not sure who that was that spoke, but I'll land my plane quickly. But if if we talk about Tesla, we got to study all his work, at least in my vein, because I'm very familiar with it. But what if there was a tree that was sort of a hybrid of something that's biosynthetic that could observe the same things? And we can go back to Tesla and talk about his work, because, the theme of the room is Nikola Tesla, but it doesn't say Nikola Tesla's coil function, in my opinion. It doesn't say Nikola Tesla's Wi-Fi function, or even his death ray machine. It just talks about who Nikola Tesla is. And I'm privy on that, and I'll say it with full disclosure. So Nikola Tesla was vast, and I think Raja talked about it anyway because he traveled. He was also a philosopher, and there's a lot of things that people don't know about Nikola Tesla, or that's out there. It's just hard to get, but you can learn about him, just like you'll learn more about Einstein. But that being said, maybe we go back to Tesla if we want to keep it narrow and focused only on, what's practical and what people have seen, or are we just hypothesizing or positing what could be and what we could do with current science and current technology? And I'll let my plane that way, and this is LS.
So I think there's a natural arc that Tesla followed, which is, I think, in my view, fascinating. I think that he starts out with his notion of high voltages being interesting, at least, and they are interesting. And he discovers the transformer, and that this mitigates, in large part, the problem with large copper wires. Only people don't quite know, how to create AC or how to consume it. I suspect consuming AC was a harder problem to solve than creating it in the first place. The invention of the AC motor, the brushless motor in particular, because there was a real problem with DC motors, and that was that they require a commutator, which is also the timing switch for the motor. And these brushes wear out, and so electricity had these several problems. It had huge cable requirements. Power stations had to be within a mile of where the energy was consumed, and DC motors were not reliable for very long. And I suspect DC generators had the same problem with the brushes. So there was a kind of a cottage industry in replacing the brushes of these motors. So his first, I think, milestone was to finally imagine the solution of how to get rid of the brushes. And this eliminates the brushes from the generators and the motors simultaneously and solves the problem of transmitting the energy over long distances, because at high voltages, the copper doesn't lose the same amount of energy that it loses at low voltages. So this is really the first breakthrough for Tesla. And his second breakthrough I think comes from his just curiosity about the high voltages. How high can I make the voltages go? And there's some images of him in rooms with sparks going everywhere, and I just have to imagine that he is ramping up the sparks. He's building transformers. He figures out that the transformers fail because the voltages get so high, and he learns how to elongate the transformers in such a way that the high voltages all end up at one end of the transformer, and for this reason they don't double back on the coils, and the coils don't arc and short out. And he kind of starts making this, what we now call a Tesla coil. And I think at first these Tesla coils created high voltages, probably sparks and arcs, and they were, pretty dangerous if you were in the way of those things. I think at some point he realized that the arcs were actually not the goal. And this is when he started developing these big spherical surfaces to put on top of the coils, because this surface is designed really to transmit the energy into the air without arcing. Somewhere along the line of these high voltage transformers that he's experimenting with, I think he ends up in a room with two of them. And this is where I think something happens that surprises him, which is that he turns on one of the transformers, as he often does, but a different transformer starts shooting sparks, and it scares him. I imagine this because I had a similar experience. At first it scares him, and at second, he tries to figure out what's going on, and this is the discovery that later becomes radio. Now this is, I think, even more valuable in many ways than three-phase power.
Well, actually, I'm not sure whether that would surprise him or not. I mean, I don't know, the era of Tesla is, what, is it 19 something? And by that time, I don't know, is it 18 or 1900s or 1819? But by that time, Maxwell's equation is completely established, and we know the induction, the whole thing is described by the electromagnetic wave, radiation, and then you have the induction changing electrical currents, generates changing magnetic wave, and then not magnetic wave, but a magnetic field, changing magnetic field, and then in turn changes the electric field, and then it will definitely drive the coil in the other whatever place you place it. So I don't see. I mean, if he knows Maxwell's equation, then you shouldn't be surprised. It must be something else that's going on. Something.
That's
fair, right? Oh, I'm sorry. What have you got?
Just a very quick comment. Something Neil said earlier. This first comment about plasma. And if you look at the Tesla coil, it's the simplest way.
Going over, Nikola's discoveries, and now you want to go back to an earlier conversation?
No, not at all.
It probably wasn't even about
No.
Tesla.
I mean, I'm not sure what you're trying. I wasn't quite sure what that discovery would be, because if it is just getting the.
Believe it or not, Hanson, I actually heard you the first time, but then I was interrupted.
What? Sorry.
Well, I heard you the first
you were
time,
saying
and then I was interrupted.
The first time I said it has to be 1 over r squared. I mean, the power.
Well, yes, there's that, right? Okay, but you were talking about Maxwell's equations.
Yeah.
I guess what you were saying was that Nikola should not have been surprised that radio happened. In his lab because Maxwell.
Right.
Well, so I mean, I think that's interesting, but for some reason, Nikola Tesla has the patent for the radio, which is the 4-coil circuit patent, and Maxwell doesn't have the patent for the radio, right? So
no, I mean you
Maxwell,
can having patent doesn't mean right now you can still patent the electric circuits, electronic circuits and everything, right? So but whether discovering radio, that's a different story. I mean, you can use radio to set up devices, invent devices. Yes. I mean, even until now, you have devices that build on the Maxwell's principle, but you can use it differently. But that doesn't mean that you're discovering radio. I'm not quite sure what that
means. The reason I want to jump in was James Clerk Maxwell's papers was published in 62 and 63, and Tesla was around 20 at the time and working at Edison's. So it wasn't popular, although it was published. But the point I was trying to bring back to Neil was that yikes, I'm losing it. I'm sorry, I'll just take a second.
Well, if I can chime in.
So Hanson, the point I'm trying to make to Hanson is that Nikola Tesla is bouncing around in his space with all of his Tesla coils. I think he's experimenting with high voltages. I don't know that he's necessarily trying to invent a device which will allow ship-to-shore communication. I think something happens in his lab that and maybe many things happen in his lab. When you experiment with high voltages, you're often surprised, if not killed. I had plasma show up on wires, in the strange places. Like, it's a very, very interesting thing to experiment with 1,000,000 volts. If you haven't done it, please don't interrupt with your ideas and comments while I finish. But it's a very strange thing. And all kinds of mysteries happen, and then you can get into, trying to work back to some principles. If Maxwell's equations explain it all, that's great. But as somebody just mentioned, it's not clear to me that Tesla is operating on Maxwell's equations like some kind of mathematician or simulator or something like this. I think he's working out his own ideas based on his experiences with electricity, and I think it's a bit more intuitive actually than calculative. And I think he comes across a practical device for transmitting information across the room, which I suspect in his case takes the form of rather, misbehaved electricity. In other words, there's a spark that happens across the room. And it probably shocked him how effective it was. In other words, how far away it was and how strong it was, because it certainly impacted me that way when it happened to me. So this, I think, is how Nikola Tesla discovered what we now call radio, and I think it was a kind of a cool moment.
To your point,
sure, of course. I mean, you maybe you're saying that Nikola Tesla is unaware of, let's say, Faraday, Ampere, and the summarized by the systematized and everything by Maxwell. And maybe that's what you're saying. Of course, that's possible.
To Benjamin's point, the telegram was just invented around the time when he approached for funding for the Wardenclyffe Tower, and he decided to compete with the telegram. So I think this was pre the proliferation of the radio, right? The radio wasn't a common invention yet. We were still trying to use the telegram to get our messages across. So I think to Benjamin's point, he did start with how do I transmit power, and then he decided to compete with the telegram, which was something that his investors did not take lightly. But there is something there about the natural progression of how he came about it.
Yeah, but if he realizes that you can transmit energy, isn't that the same as transmitting signal?
Could I comment about that?
Yeah, well, hold on,
Hanson,
I kind of isn't that contradictory to the narrative that he's unaware of the knowledge? It could be that, of course, it's possible that he discovered them all, the radio and radiation and electromagnetic wave. I don't know. Is that you're claiming?
I can speak directly to this point. Remember also that it's not just Maxwell who established the basis of the electromagnetic radiation. Hertz was the first person to make a practical demonstration of radiation. This was 1887. This was in 1887, which is actually a little bit after Tesla's. Tesla was already trained by then. So when Hertz did his experiments in his lab, it was 1887. What are the dates that we're talking about for Tesla?
Okay, so I don't know.
Late 1800s, late 1800s to early 1900s.
Yeah.
And just to add another point though, relating to Tesla, Hans Kohler invented a free energy device in the 20s, and later the British was patent for it, which was taking Einstein's point. I think it was Brown, if I'm correct. And he was inspired by Einstein of his grand unified theory on matter, gravity, and electricity. So this work is always being built on others. And so I think we should always keep it in mind while talking about Tesla, because I think Tesla did most of his patents prior to when he was meeting with Edison. So I think he had a lot of, they weren't granted, but a lot of them came, if I'm correct, and my memory could be off, before 1920. Or before that time span, and the rest of it was just him experimenting and trying to perfect other things and sort of branching off. But those patents he still has awarded to him, and a lot of them, because he wanted to be first, at least in the U.S., I guess, to patent that information to show that he had did the work. But then others came to perfect that, and the Germans were working on this. Kohler did do that. He had a hands-free energy device that could power submarines and sort of quote-unquote spacecraft. And this is before World War II. This is, after World War I. And this is what it is. This is fact. So, yes, scientists are working on these things. Can they perfect and build on them? We learn, we grow, and we understand. And I think if we think of Tesla, we think in that vein so that we can understand sort of that hybrid, because, a lot of people think what would have really happened, had the Allies not won World War II. And I get deep about it because I study the science of it. And I'm just talking all engineers, all scientists from all parts of the world. And you see what's there. And so a lot of that technology will iterate. It gets perfected, the World Wide Web. Right now we're on 5G or 6G in some countries. And Ericsson was the first to start the radio, towers. I think Hans or Neil, you were speaking about that. But Ericsson, the company, Sweden, I think they're in Sweden, if I'm correct. They were the first to roll out with the 1G and everything else. So that's who you would look at, because they publish a lot of those papers scientifically on mobile towers and what the frequencies are.
Hanson, also, Maxwell was a theorist, right? And Tesla was an experimentalist. So I don't think there's a problem. They both did their part.
No, I know. But what I'm saying is was he aware of the Maxwell's equation or the Faraday, all the Faraday laws, Ampere's law, and all that stuff? When he was doing it, that's the question, right? So, messaging me saying that Tesla was born in 1856, and Maxwell published his equation in 1861. So that when Tesla was 6 or 7 years old. 5 or 6 years old, the Maxwell published his equation. So I don't know. Did he know that or not? Did he learn it after, in his 20s or something, whatever? That's the question, right?
Hanson, it's my impression that Nikola was more hands-on and less theoretical. He did a lot of work in his mind, which was imaginative and creative, but it was probably informed by his hands-on experiments and not by formulas and math.
Yeah, but you can, people can translate the formula into the kind of intuitive ideas. So, for example, Faraday, who precedes the Maxwell's equation, he actually invented this name for the magnetic line, and then described the magnetic field and all that. So yeah, I mean, it doesn't. I mean, you don't have to compute solve differential equations to understand it. But I mean, the question is whether he was the knowledge by that time transmitted. I mean, did he absorb the knowledge before, or did he completely come upon it by himself?
Well,
can I comment on that?
Oh, I'm sorry. I was going to say one quick point, Neil. Hansen, some say Tesla was a savant, and if you think of like Beethoven and writing certain symphonies, or these people that come along, but he would reverse engineer it to mathematics. And once he built it, and I guess I'm agreeing with Benjamin, my understanding is, Tesla would just build something, see it in his mind, build it, and some say he had, an event when he was early, in his early age, like 9 or something, and I don't know if it was, I won't call it extraterrestrial or whatever, but he had a life-changing event that messed with literally his brain, and since then he was changed and he could just do things. And then he would see them, but he would document them. At least I have his papers in physical form later, and how they're constructed. So I think there might be two approaches, because you're right. The theoretical is that every thought and idea does come from the mind. I mean, it's abstract. We do it and then we build it out. But there are some who can see things, and I call it reverse engineering. That's just my terminology. Like, they actually already see it. They know how to build it. They can build it, execute it, and then tell you what parts go in it after. And they just built the perfect machine or car engine or whatever. And those people are very rare, in my opinion, but they do exist, and that's all I'm saying.
I'm one of them.
Yeah. I understand the reverse engineer. I mean, the reverse engineer means that you already seen the product. It couldn't be reverse, because otherwise he wouldn't have invented something new, right? So I wouldn't say the reverse engineering. Yeah.
Could I put another data point in for consideration? The looking things up a little bit, I see that the first time that Hertz, who is in the standard physics community, is given credit for being the first person to take Maxwell's equations and actually produce a theory of practical radiation production, electromagnetic production. That was he published his paper in 1887. Now, this was the same year in which some patents, but I'm not sure which ones, by Tesla were also filed. So the Wikipedia article on Nikola Tesla, is not detailed enough in the version I'm able to access to tell me which patents, which of the radio relevant patents was given when. But he made some patents by 1887, which is the same year when Hertz broke the news that there was something really, practical about the concept of electromagnetic radiation as displayed by as the theory had been created by Maxwell, and I believe Hertz is considered to be a pioneer in that sense, even though he didn't create the theory. I mean, he was basing his work completely on Maxwell, but he was the first person to make it real, as opposed to a physicist, I should say, as opposed to Maxwell, who propounded this great theory, but nobody tried to do anything with it up to that until Hertz did. So anyway, the point being that in a way this confuses the matter a little bit, but it pushes it off. I guess the question would be, when did Tesla file his patents on radio, or when did he do his work on radio as such specifically? And then if we knew that, we might be able to tell whether he did his work before or after Hertz. I think before or after Hertz is probably the more relevant question than before and after, and whether or not he was schooled in Maxwell's equations in school in university. Probably he was not, because Einstein was already complaining later that nobody was talking about Maxwell. So anyway, that's my thought, my question, my contribution.
1897, Neil.
I think it's relevant that until the 90s, he was focused on motors, electric motors, transmission systems, trains with electric motors, etc. It looks like in about 1865 or thereabouts, he starts to become interested and starts patenting things other than motors, for example, apparatus for producing ozone. But we have here 1896, apparatus for producing electric currents of high frequency. And I think this begins the search, his experiments in high frequencies. And I happen to know that in about 1900, he's going to file the 4-coil circuit. And that is the circuit that Marconi initially defeated, but then later was overturned. And the invention of radio was allocated to Tesla. So I think that there is some theory in Maxwell and theory in Hertz, but a practical device that can handle large currents at high frequencies and produce the kinds of phenomena required to demonstrate radio communication at an interesting distance. I think this falls to this work that Tesla is doing.
So you're giving about date of 19-something or 1890s or something for Tesla's inventions in radio, more or less?
Yeah, I think
1897.
His patent record shows that he becomes interested in that around 1896, and by 1900, he's patenting, a radio. But it is a fact that he views the value in terms of communicating power, more so, but not exclusively, to communicating information. And Marconi obviously, takes the other tack that this is a device for communicating ideas, text, ship-to-shore radio, etc. And Marconi never takes up the interest in moving power per se.
Okay, so these are scientific histories. It's pretty well recently established. We have Maxwell in 1861, Hertz in 1887, and Tesla and Marconi, I guess, 1890s or so, right? 1897, you're saying. So there's a sequence.
Tesla 1897.
1897.
Yeah.
Okay.
There is a sequence.
So there's, it's kind of hard to argue that he's not unaware. He's unaware of the work of or the consequence of Maxwell's equation, or even the Hertz demonstration of radio before he had worked on the transmission of energy, transmission power, and the information. And transmission power and information are just the same, one and the same.
And also,
yes. However, I don't know that Maxwell demonstrates, the long distance communication.
Why does
Hertz?
It's all in the equation. I mean, the Hertz demonstrated an actual device that the transmitting the actual, the experimental evidence to show that's correct, and the wave is everything is in the equation.
Yeah, but Hertz is publishing scientific papers and Tesla is publishing patents. I think there's there's a difference there.
Yeah, I mean, the thing is, you need the principle the principle to know to build the device. I mean, that of course. I mean, even until now, there's still people finding patents for electronic circuits. But that's all built on the Maxwell's equation, and of course other things, quantum mechanics and everything.
Hanson, if I could just add a footnote on both points of you and Benjamin, is that I've got 3 patents and so forth for my company, but I will say that there's always been scientists working on. They say this in historical that there's 2 people who are not connected and working on the same similar project. And even Einstein, he worked at the patent office before he got recognized. But there are some who were saying they were working on the general relative theory while Einstein was even doing it. There's a lot of talk. So I do believe, I've encountered it, some will call it quantum entanglement if you really go further about it. But I think when there's a certain shift in the human psyche, and that's just my personal belief, it can affect another person that's not known to the other person, and they will be working on the same similar things. Now, one can reach, that particular, like I was talking about Kohler's energy device. Hans Kohler didn't get the patent. It was actually a British scientist that got it 5 years later because they rejected his patent, and it was for the same device. And I think it was like 5 or 6 years later, in the 1926 or something, that a British person got the patent, even though Hans Kohler had built it first and had it out there. And it filed a patent but got it rejected. So sometimes we just need to be, holistic, because legal and everything may not be first, but that doesn't mean who's the first to invent. I mean, we're all learning from each other. I mean, no one's, in my opinion, bringing anything new.
Yeah, no, I understand what you're saying. I mean, people can work in parallel, unaware of others' the invention or discovery. But that's my question, right? So I mean, I kind of think in this case they're not working in parallel. There are decades between the Maxwell's equation and then Tesla's filing of the patent. I mean, you can argue that they can. I mean, he's working in isolation and discover the whole thing himself, but it seems to me that's a little bit unlikely. Not a little bit unlikely, kind of quite unlikely. But we can look into the to settle it. I mean, it's completely possible that he's unaware of these things. But I would think the contrary would be true, because Tesla must be a very a absorber. I mean, of knowledge and a quite very astute absorber of knowledge. And I wouldn't think that such a large, profound discovery he wouldn't have been aware of and studied on it. But of course, the final nail on the coffin would be find a biography of Tesla and to see whether he has any notes, you can say where Maxwell or eventually even Hertz discovery.
Yeah, so just for reference, I'm sorry.
Sorry.
I'm looking at an article. Or are you looking at an article about Hertz and the induction coils and the circuits that we're talking about? So Hertz has the induction coil, and the circuit is it's a little bizarre. I would have to say this is probably a transformer, but basically it's two coils that are in magnetic proximity. By looks of this picture, only, maybe 4 to 6 inches apart. And by the schematic, there's actually a wire that connects the two circuits together, so it's not even an isolated, there's not even a gap between the transmitter and the receiver in this drawing. I just don't think that you're talking about the transmission of radio waves the way we think about them as radio waves. I think what you're talking about is a magnetic induction system with Hertz. What
Same thing.
Tesla...
What's the difference? I think you just don't know the principle. I mean, it's the same principle.
Yeah, it's the exact same thing.
What's the difference?
There's a lot of interest is made between inductive coupling and radio coupling. The apparatuses are entirely different.
No,
it's the same thing.
The thing is
everything is the same thing, Hanson. Everything boils down to quantum, realities, right? So everything is the
don't
same
even
thing,
talk
but
about
that doesn't
quantum
inform
mechanics.
us.
Just go. I mean,
we're all quarks, right?
Says it all.
No.
Okay. I mean, the Fourier equation says it all. Just go solve the equation, and it's the same thing.
I just want to suggest that maybe we should wrap up soon because, there are so much points about Tesla that the other kinds of audiences would have appreciated if we had presented it now. And I really appreciate the kind of discussion that we have because it makes us think. Yeah, however, I think just like what Hansen said earlier, to nail the coffin in the head, let us examine facts or whatever had happened in history, probably to discuss this again when we open a part 2 room of Tesla. Because I've been receiving messages from the back channel also that in other parts of the world wherein there are regular listeners to quantum photonics, it's already getting late and they would like to listen to you live next time if we have a part 2 of the room. And maybe by that time, the questions in our head have been better processed by us and we have had made more researches to settle this very important question that, we are asking here on stage. So, that's what I would like to tell the room for
Cecile.
now.
I think Hansen raises interesting questions, and I'll be interested to answer them in the next chapter. Thank you so much, Hansen.
Yeah, fantastic. I can look up the biography. I'm sure there are many biographies of Tesla.
Yeah, I think it's a technical question more than a biographical question myself.
What you talk about, the technical question, I mean, all these answer, the technical question is just in the Maxwell's equation. Go ahead, Cecile.
I will just check what is an open day next week. I hope, a day like this Friday next week is open, but there is an open room again, I think early or middle of next week. So we shall set this. Maybe we... if you like, if we have a Tesla part 2, because that MJ was here earlier and he wanted to talk about, the common things that we know about Tesla and a little bit about history and maybe some other discussions in other fields. So I was thinking to already make a part 2, but in terms of, what we're discussing now, it's also worth discussing again when we have maybe processed more and checked on how we would be able to address the question. So, if that's okay with you. I didn't mean to cut off anyone who is still in the middle of this discussion. But, I think it's like getting late. And if we want to add better dimension and richness to the discussion, it's better to have a fresh new room part 2 of Tesla. Yeah, so I hope you will be free next week. I look for a date to set this.
And Cecil, this is LS. I love it. I would just do like Tesla and the impacts of what he was researching, how it's been built upon. That way we don't get, we can all come and collaborate. And it's not about, let's say if it's Maxwell, it's not Maxwell. Because you're right, we can all spin down this, especially me even, down this tunnel of, I know Tesla economic system was not good personally. So that's why Edison, sort of got the advantage over him because he didn't know Tesla wasn't good at business. This is a fact, from a lot of people. That's not true. Well, okay, so I'm sorry. Let me land my plane. Let me land my plane. So we don't do the back and forth. But that's things I have, and I can bring that evidence and proof, and scientists or people who can do this. But the more bigger impact discussion is how has this research and these scientists, not just Nikola Tesla, but like him, have built on, this future of building companies and what we can do. And it's peculiar to me because I think Nikola Tesla, and it was popular way before Elon Musk joined Tesla, and he joined it 6 months later because it was 2 Stanford engineers who built the company, okay? So just to be clear. And then Elon came on, and he's just great at branding and doing these things, and he's a scientist as well. But I know of the 2 Stanford engineers who built Tesla car company. So we're talking about this because it was electric at the time, and it was innovative, and it was cutting edge. And so it's like, how can we talk about this in a greater discussion so all people can learn? And it's not just, in my opinion, it's not just a debate, because I don't believe in it either. I want to learn. I got one mouth and 2 ears. I like to listen more and speak less and learn and then research. That's just who I am. And so, and be humble about it if I can. So, and not dogmatic, because I wasn't there. That's just how I think. If I didn't live there, even if I read it in books and I have thousands of evidence, I wasn't there. So unless I was there, I'm not going to be dogmatic about it. I'm just going to say, okay, I'll look at it objectively, and as much as I can as a human being. But that being said, we can help people grow and learn, because it's the impact of these technologies and what's coming in the next 8 years on AI, AGI, quantum, all these things that we're building on and what we'll build as a future. And that's what quantum phonics is about. That's all I'm saying.
Excuse me, this is Neil King. I would like to suggest that it might be helpful if before we have another meeting, we have we have an agreement of what are the main questions that are to be addressed. Otherwise, we're going to have, again, people chasing each other around in circles, arguing different things that may actually not even be argumentative. But if we have some idea of what questions you're trying to answer, that would probably be helpful.
So, Neil, I don't think there's any chasing here. These are the real controversies of Nikola Tesla. Nikola Tesla's patent for the radio spent a decade in the courts of the United States. They were overturned. It's a phenomenal story. I don't think there's any question about what the important controversial aspects of Nikola Tesla are, in my opinion. And they aren't the branding of the Tesla motor company by Elon Musk, as an example.
No, it's the question is when Nikola Tesla invented the radio device.
What we will discuss.
Yeah,
go ahead.
So the question is, when Nikola Tesla invented his radio device and patented it, was he aware of Maxwell's equation and its consequences? Even maybe not Maxwell, the name of Maxwell, but is he aware? Did he study the knowledge of electromagnetic wave? And the second is, was he aware of? That's the first question. Second, was he aware of Hertz's discovery of radio wave?
So
it's more complicated. The question at the patent office, Hanson, is more complicated than that. The question isn't who discovered radio waves, because radio waves is just a word. The real question is, was Tesla's apparatus original, unique, and did it provide a functionality that
No, that's not the question. That's not a question, because
that's the kind of question that a patent office answers, isn't
No, that's not the question. I mean,
let's just wrap it up for now and put a pin in it.
Yeah,
Yeah, I agree. Let's wrap it up. Hanson, guys, Benjamin, please. Let's do it on take 2, and let's make it broader, in my opinion, just suggesting. So we don't do tennis ball. We're playing a tennis game or ping pong, and that's not, I never try to do that. And sometimes I'm a victim. Let me be clear. I've been accused of doing
this. You're not adding value to the conversation.
Well, she's trying to close it down, the room, and we're not respecting the women, and all these men are talking. And so all I'm saying is that the moderators are saying, let's close it down and move it to next week, and we're still talking.
I think actually you're engaged in the game of trying to have the last word for some reason.
Benjamin, you're just trolling.
Yeah, I don't think so. I'm the only one here who built a Tesla coil, Lance. I know what the fuck I'm talking about.
Yeah, I don't want the kind of conversation here in the room because we had been listening to you. So we try to respect everyone as much as we can. And it's not because I'm a woman that I should be respected. It's because I'm a moderator here and I organized this room. So this room should also be respected in the manner that we try to conduct good arguments also and scientific arguments. And even in debates, there are rules. So, we are planning to close the room, not with some kind of displeasure, but in fact, maybe with pleasure to look forward to another room wherein we have segmented some topics because there are so many aspects in Tesla's life and his invention that should be shared and understood and known by some people who had known him. So I will not hurriedly close this room, but anyway, I would like to announce the next room that we will have in about maybe about 14 hours from now. We will have the future of education with David Wood, who is the chair of the London Futurists. And a few hours after that, we will have a room on longevity with Dr. Dana LaRocca. And the night after that, please remember Rishi and Hansen, who are our regular moderators here in Quantum Photonics. We have Garrett Lisi coming back here again. Hansen, you had, and Rishi, you had inspired me to invite Garrett before, so please make sure to be here. He will discuss about Lie algebra as well. So, I hope you will follow Quantum Photonics and come back here. And in the spirit, of good conversations, and also we do not discount that we probably will not agree with each other in any kind of forum, which I also would like to encourage because that is the spirit of learning and rationality. And so anyway, let us just maybe re-examine, and maybe it's also good that we have an outline of what we have, because earlier I thought this is going to be a short room, as this is just a pop-up room since we have no guests, and that's why I made this. But I think the topic has a lot of dimensions that it inspired a lot of people to stay here for several hours, and we had many visitors today, including Lex Friedman. So we shall make another room for this, and please spend the night with some inspiration that we are all thinking people, and that we should be able to agree to disagree. And so because of that, I would like to say have a pleasant evening, and I would like to give the mic to Darcel.
Thank you, Cecile. Hey, everybody. I really enjoyed this debate. This is great. I mean, I'm learning so much, and it's just good that, like she said, we can all come together, these great minds in this room, and agree to disagree. That's what it's all about. So, so we're all going to sleep on that one, and I'm going to count everybody out. We're going to start with lucky number 7. Is everybody ready?
Ready.
Here we go. 7!
7.
There we go. Route 66.
6.
5.
5.
4. 3. More 2 X. 2.
2 X.
Cecile, Rajarshi, Sierra, Hansen, Benjamin, Jake, Ali, Neil, LS, you are all number 1. Go ahead and call it out.
1. Yeah, thank you, everybody. Thank you for coming and for your support. And thank you for being smart people all here in Quantum Photonics. We love you all. Good night.
Good night,
Yes,
everyone.
have good dreams.
Sleep well.